Hello, hello, hello. Hopefully we are all good. Another impromptu learning stream. I very much enjoyed doing this on Thursday. Very late into Thursday night. So we're actually doing this a little bit earlier. Mostly because it's a Sunday and I do actually have to be up somewhat early Monday mornings. But yeah, we're going to be doing more Vulkan today for anyone who missed it last time. How far did we get? Okay, for anyone who's not well versed in Vulkan, very powerful, but also very lengthy to set up graphics API. And I'm learning it because I want to, just because I fucking feel like it. There's a lot of different steps that go into getting Vulkan going, and I've completed, I want to say half, roughly. I've done a lot of like very careful developments. Like I've built like really nice error checking and all that kind of stuff. So it's probably taken longer than it would if you were just speeding through your tutorial, but I do still have a decent bit done. We have a Vulkan instance. I actually off-camera made a Vulkan surface, but don't worry, you didn't miss that much. I'll show you all that in a bit. Selecting our physical device, so the GPU you're actually going to render to, or render with, and creating a logical device, which is basically a subset in Vulkan that then contains all of your the various extensions that you want to use and whatnot. Actually, just gonna bump some code around here real quick. Don't you worry a thing about it. We will be all good. Just tidying things up a little. Right. I think we're in a good position to start. I might want to switch out our music actually real quick. Let me switch over to this. Oh no! I forgot her! Hold on, I have to put her back. The chair is empty. Hi. I just realized I probably don't need a game controller in this case. This isn't a gaming stream. The doodle just wasn't fucking there. Lol, see ya. Empty ass beanbag. Yeah, we're good, we're good. Right, hello. Let me throw on... I had a Lo-Fi Beats playlist that I frankly just need to like pin somewhere. Sure, this one will do. It's like an hour long. Yeah. Why is the moderator icon a sword? I never questioned this before. They're the guards defending the gates with their swords of steel. That's my headcanon anyways. Hopefully this volume is okay. That should be fine. We will turn that down a little bit actually. I'm gonna kill you with my sword. Julia would say this. That's what you get for being for air jailing her over and over again. She will be doing the air jailing from now on. You know what would be really nice? In fact, you know what? Fuck it. We're gonna try it now. We're gonna try it right now. In real time. I don't have a chat source, and I would really like a chat, like, thing in the corner. So let's do stream place chat. Yeah, you can't see that browser source. Good, you're not supposed to. Hopefully this link will paste. Yes, it will. Yes, it will. I don't really know what would be a good size for this. So we're gonna do that and this maybe. Let's see how that looks. It's interesting. I feel like I would want to give it like something of a backdrop here. Just a moment. How does this feel? Slightly better. What do you think of this? That's not even nearly large enough. Let's try something else. We'll try font size 24 pixels maybe. And I'll make the width larger. Yeah, no, don't worry. I'm gonna do what I can to fix it. Okay, that just did not affect the text size whatsoever. Perhaps if I do, I need to actually like live debugging. Hey, for these streams, it's actually okay for me to do that for what it's worth. All right, let's see. What is the font size for this based off of? Okay. That's... Not immensely helpful. Oh, no. Yeah, that's actually really unhelpful. The font sizes in the embedded chat are like exact pixel font sizes that are specified as like inline CSS. I am very unlikely to be able to... Oh, I could probably override this, but oh my god, it's going to be painful. We'll try it. We'll try it. But I think it wouldn't hurt for me to build my own custom chats. For what it's worth. Okay, that override I think worked. Good, 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 good. I'm pretty sure I had a drop shadow on my text. Let's try this real quick. It would be text shadow like this. Does that work? It doesn't look like it's working. Oh, my bad. I'm doing the wrong thing. Okay, that might be easier to see. We'll try this, and I'll make it like that. I'm really just like throwing shit together, see what sticks. That's better. It is a little bit better. Let's see if we can improve it. Give it a little bit of a blur. I think, maybe. I mean, realistically, I'm giving it a hard time by putting it on this kind of a backdrop anyways, but, you know, it's worth trying. It's worth trying. Submit a PR to stream place to not have specified font sizes. Oh, to have that. Yeah. Yeah, could do. Part of me does wonder, would it be easier to build my own chat widget? Because that could be really cool. It'd be an interesting little project. But I do have other issues with the chat thing that I would want to submit a PR for. A simple one is when I started, I noticed that it didn't min height 100%. So the send message box at the bottom would be like up at the top of the screen until enough messages like filled it out. I'm assuming that's not something that had really been tested. I probably don't need times on the screen either. I can probably just outright exclude those. So we're just gonna put that in a display none. We really do not need times in the messages here. How's that looking? Did it just... Yeah, it's display none to everything, so that's not what I wanted. What? I'm sorry? Display none. Oh, yeah, it actually hides the whole message. What? Excuse me? Oh my god. Oh, this is gonna be so rough. I think I know what's wrong. Let's try this. The container for the timestamp and for the message is like the same CSS ID. So I have to do some like extremely hacky shit to make this work. We will make it work though, one way or another. I think it would be like... No, that doesn't do it. This is tricky. Why does... Oh, Firefox. Nasally.sh, please, figs. It's first of type, right? MDN first of type. I'm pretty sure that's what it is. Yeah. Oh, I did get it wrong. That's on me. It's first of type following the CSS name. It's not like one of those first of type and then brackets. Let's try this. We're so back. That's more what I was thinking of. Good. Okay, let's say I get rid of the backdrop altogether and we just want text shadow. Let's give that a go. And I'll maybe strengthen the text shadow as well. That's much easier to read for what it's worth. CSS is not a goblin language anymore. Modern CSS is really neat, actually. There are some nice things in CSS. Okay, now let's see how that looks here, which is an outdated monitor view, if I see this correctly. Oh, there you are. Yeah, cool. Cool. Let's see how that looks over here if I paste in a reference. So that's just too big. Tell you what, I will crop it like here maybe and chuck that up at the top. That's better. That's definitely better. Let's say we will maybe still have the background color in here, but I'm going to also round the borders, make it look a little bit prettier. The things I do for legibility. Border radius, let's do 4 pixels should be more than enough for this. Let's see. How's that look, everyone? We thinking good? Let's look over here. It looks all right here. I don't know if that border radius thing actually works at all, to be honest, but we ball. It's not the most readable on this screen, is it? It's very readable up here, but like, duh. Okay, I'm gonna strengthen the shadow, I think. Let's try this. It's better. Yeah. For the sake of actually getting into it, I'm not gonna ham on it for far too long, but yeah, that's something. I'll maybe build a custom widget for that at some points in the future, because I also would like a universal one that works across both Twitch and Streamplace, because I now stream to both, and I don't really like having to dick around with multiple different chat things. And also, because I'm using like generated CSS classes, I bet you next front-end update, all of those are breaking. The timestamps in chat look terrible in the mobile app. They line wrap in the middle of the minutes play. See Discord or screenshot. Oh no, really? Ooh, that's not ideal. That's unfortunate. Oh yeah, if any of you are on the Discord, I did mention it in the livestream chat, but we now have a dedicated role for catching Arya's learning streams. So if you want to be updated on these streams in particular, and you're on the Discord, you should definitely make sure you have that role in the Discord, because I'm not going to be pinging the regular live role anymore. Arya Melody Live is a gaming show, basically, and this is like a recreational programming, more chill kind of vibe. And critically, not organized, so, you know, if you subscribe to that role, you are subscribing to being pinged at any time when I feel like doing this. Not on a schedule. All right. Wonderful, wonderful. So, where were we? Yes, I got a couple things done. So we already have our Vulkan instance, which is delightful. Very happy to see it. We have create surface. This one is super simple, because SDL does it for us. So that's fine. We then just have to clean up the surface after the fact, but then we're fine. Like, everything's all good at that point. Physical device selection. I did improve this slightly. There were a few things that I fixed. I think I built a proper abstraction wrapper around some things. And also, device selection now gives you some slightly better logging on stuff, so I can actually show you this. I love the output of this. There we go. GPUs detected. And yes, it does detect both my GPUs now. It was a driver issue. It was because I just updated drivers during the stream. But yeah, NVIDIA GeForce RTX 3060 Ti, discrete GPU, and then other details probably don't care about. Something I am very much thinking of doing is grabbing this API number, because I actually think that this is something I can compare against... I think it's VK API, yeah, version 1.4. So I can essentially go through a list. In fact, you know what? I'll do it here. We'll do API version, And we're going to do if-else blocks here because it makes the most sense. So if VK API version 1. We'll do properties API version. If it's greater than this, then we can say that it supports Vulkan 1.4. And we basically just do a whole bunch of more else ifs at this point. If there's a better way for me to do this, please let me know, because this is all that comes to mind right now. This is my yandere dev moments, but I think this actually does make some amount of sense for what it's worth. And 1 and cool. We'll do if. Oh, actually, it's going to need to be greater than or equal to, isn't it? That'd be ideal. And I mean, let's be real. The device will have already been like knocked out of consideration, I think, by the time we do this. No, we do grade the device beforehand, but yeah, we will want to track its Vulkan version if it is at all supported. We can't really predict higher versions, so difficult to say. But yeah, that should be okay. This should be okay. So here we'll then do API version. Let's see how this works. Vulkan 1.4, bada bing. In fact, we don't need to say the version of Vulkan. Just giving like the 1 dot prefix, I think, is fine. Yeah, API 1.4. Driver versions, this is very much like I need to vendor in like NVIDIA API stuff. We don't need to go that deep in the weeds. The fact that I'm doing this is already overkill. Oh shoot, wait, you can't really see that properly, can you? Apologies. Here we are. Discrete GPU, API 1.4. That's all that's supposed to be doing. You could have probably done a switch case for that and then do a check in default if it's over 1.4. Can switch cases do, like, integer comparison, though? I thought they only checked equality. I'm not aware of being able to do greater thans in a switch statement. Because keep in mind, API version, like, this is like a hard-coded number, basically. And the API version can be many revisions after that number, so I can't just check if it's equal to VK API version 1.4, because that would mean that it supports literally like the first release version of 1.4, not any of its patches, which, Vulkan info, let's see, just a summary is okay. Yeah. There's been a couple patch versions since then. And like, yeah, we got driver version here, and that is helpful. But I don't know if there's a really good way for us to pull that without then vendoring in NVIDIA stuff. Maybe there is something for it. I don't know, like, I'm not really seeing it. Yeah, I'm going to say no. There might be another include in here. Yeah, that's probably going to be a no. Worth looking at, though. But for now, this is, I think, fine for what we want to do. Yeah, we have physical, or yeah, we create the surface, and that's like another big step. You'll notice though, we still don't actually have a window. We have this little Wayland stub over here, but it's not actually doing anything. And that is because we actually need to still present something to it in order for Vulkan to, in order for Wayland to consider drawing it to the screen. I think macOS is totally fine opening a window at this part in the process, and Windows will probably be the same, but Linux, big mad. Linux, or Wayland in particular, big mad. X would probably work, but I really don't plan on supporting X11, to be honest. Like, this particular engine, if people say, oh, it's not working under X, I'll like, if you try Wayland. And I know Steam Deck is a concern there, but like, I very much personally see X11 as like a dead platform. It's on life support, and we should be using Wayland. X11's about to stop being properly supported. Yeah, exactly. Isn't it KDE are going to be dropping X11 support at some point, or was it a distro that uses Plasma? Either way, like, vendors are dropping support, and it's about goddamn time, because ever since I started learning more about how Wayland works, the more delighted I am by Wayland. Yes, on most platforms they will show a black window. Wayland only displays a window when it is mapped when you first attach a buffer. Yes, and that's actually part of how they prevent VSync issues, isn't it? They basically enforce VSync on a protocol level because you have to present a full frame before Wayland will even bother showing it to you. So this window technically does exist, it just doesn't actually have a frame to buffer yet, so it doesn't bother buffering it. KDE is dropping in August. GNOME is dropping it this month, if I recall correctly. Fedora should have dropped it already. Well, I mean, I'm certainly okay, because I've been on Wayland for like a decent amount of time. I remember I was on X11 very, very briefly when I first like switched to Linux full-time. And it was purely because like I wanted Wayland, but some apps like behaved weirdly because they were running an X Wayland and shit. It turns out a lot of those apps actually did support the Wayland backend. They just didn't have it on by default. Discord was like a huge example of this, but that's kind of not a problem anymore. Like all my shit just works. Like Discord even supports the KDE like window select and everything, so which means it supports Wayland because that's a desktop portal, if I recall correctly. I used X11 for around a week, got annoyed at the weird login graphical issue I had to move to Wayland. You know what I hate the most about X11, actually? It's not even the fact that it does not support multiple monitors at different refresh rates. It's not even the fact that, like, yeah, you can have weird graphical issues just because of driver support. The thing that annoyed me the most was middle-click paste. Who the fuck thought that was a good idea? That's terrible. And like, I have it here in Firefox for some goddamn reason. I think this is an X11 app, even though I've tried to tell it to use Wayland in the past. But yeah, it's weird. Anyways, moving on. More Vulkan stuff. Yes, so a window surface. I have basically gone through all of this. It is so stupid simple. In this case, in the docs, they use like a Win32 surface, but they do specify... yeah, it doesn't make any sense to use a library like GLFW and then proceed to use platform-specific code anyway. But yeah, it's demonstrated how to create a surface on Windows specifically, but we do ultimately just use GLFW to create the window. Yeah, there we are. And then we'll fail if that fails and whatever. But yeah, that's it. We now want to query for presentation support, which actually, that was something that I did do under the hood as well. I believe that's in, is it device selection? Yeah, because you'll notice create surface, even though it's done, I did it after these steps, they did specify in the documentation, there's a reason why that's done here. And it's because creating the surface can actually help determine some stuff on the physical device side. Or rather, you'd kind of want to know, like, you can create the surface before selecting the device. But yeah, I did, in Grade Physical Device, I did improve how we select required features and stuff. Oh, and extensions. Yeah, extensions were a big one. This should probably just be fused off under SL debug. Oops. Yeah. Weird. Why does this... Huh. That should be on. I think I know what's up. I did also improve the build pipeline slightly. This is just a personal thing. There's now a separate directory for debug and release because I actually wanted to send a build to a friend to test, but they didn't need all of this debug stuff. And this does actually slow things down and would actually break on a lot of systems because the Chronos validation layer is required in debug builds. That is a thing that I have now. Oh yeah, I did fix my SDK as well. That was a me problem. I will address that very shortly. But yeah, so basically debug builds aren't meant to work on other systems. You kind of need the SDK in order for it to work properly. The release build skips all of this stuff, so that's all good. But yeah, I was sending a build to someone just to test to make sure it detected their GPUs. Funnily enough, did not detect the DGPU. It was like a hybrid laptop, so it had an iGPU and a DGPU, and it didn't pick up the DGPU. Like Linux knew it was there, but for some reason Vulkan didn't. Kind of bizarre. Not sure what that's about. Because I don't know how I can ask it to be, like, more detailed in device enumeration. Like, I kind of have done what I can as far as I understand it. You can disable middle mouse paste in Firefox config. It enables it internally even if your compositor tells it not to. That's so fucking annoying. Yeah, I'll have to look at that again at some point, because I remember it annoyed the shit out of me. And I think it was multifaceted. I think it was a thing enabled in Firefox, and it was running an Wayland. So, config key is middle mouse dot paste. Let me have a look. Yep, it's set to true. You bastard. Actually, I'm not going to do that because there's a couple other things I have open. Oh. Wow, it's immediately fused off. That's fantastic. You'll have to see it. Thank you. Right. Yeah. Oh, yeah. Querying for support. So we need to query for two things in this case. We were originally just querying to see if it supports graphics, which is like, you know, pretty likely, but not necessarily guaranteed. Like, you can have a GPU that's like just for AI and doesn't actually really do graphics compute. So that's something we do need to check. If I go into required device extensions, we demand swap chain support. Yes. I have tidied this up a little bit as well. I should probably just open source the code that I've got, to be honest, so that folks can follow along if they so wish, but haven't thought about doing that so far. Enabled device extensions. I swear I do something else here. If supports portability. Oh yeah, I did get a warning on macOS in the past that, oh, if your device supports the portability extensions, you should enable them, the portability subset. So I now have an if statements that like checks if that's supported, and then we'll just tack it onto the list. Enable device extensions. And that gets enabled and required. Maybe it's not in device. This might be an instance extension. Where exactly did I specify this? Yeah, I think it's here because I do 2 SDL mem copies. Yeah, we have the SDL extensions, which includes things like VK. Yeah, that's VKKHR Surface and Wayland Surface. So that's what is proposed by SDL. So we have to enumerate them there for it to work with SDL. And yeah, we have to require them because SDL requires them. ext debug utils is a me thing, I believe, but I think that should be fused off. Yeah. Let's see, does this work? Recent compile. Oh, it hated that. NVK extensions is what did I do there? Huh? Oh. Huh? Oh, this is just code I hadn't, like, tidied up yet because I had this whole thing fused off in the first place. Yeah, I want to be more verbose with my variable names because I was getting confused between device and instance extensions. So that just made it a little easier to read. Yeah, here we are. So now in debug mode, we can now list all of the extensions that are supported by all of the devices. But like I said, there's a reason this is commented out. This is also kind of annoying because it makes the logs kind of unwieldy. But we can see we support extensions. We absolutely do. Yes, there's instance extensions, which is, I think, more of a Vulkan specific thing. And then there's these device extensions, which is more down to the driver and the hardware, as I understand it. It's supposed to be off by default depending on a specific protocol's value. I don't know if Katie implements said protocol, though. They don't implement it? I swear I've seen this before, though. This will interfere with applications use middle button drag. Yeah, okay. I swear there was a paste thing. Although it's possible this was X11 only that I saw this. Yeah, huh, maybe it just isn't supported. Oh wait, middle click paste selected text. They do have a thing here. Yeah, that's what I was thinking of. But maybe they don't actually forward that through Wayland or portals or however the hell that's supposed to be communicated. Kitty is a value, but not the protocol. Why is the value there? That's so weird. Anyways, yes, the SDK stuff. I was going to explain what I did there. I was editing my NeoVim config, don't mind me. Yeah, so it turns out that whole build thing I was doing the other day did not need to do that. That was actually not at all what you're supposed to do. What you're supposed to do is, yeah, I've created a symlink for latest just so it's easier to do this. You literally just copy what you download from the tarball into wherever you want your Vulkan SDK to be held. And then in my config, like my shell config, I source in setupenv.sh, and this contains a bunch of stuff that loads in Vulkan SDK stuff and LD like library paths and stuff, and where layers are and all that jazz. And that gives me the Cronus validation layer. So now I will get little warnings if I'm doing things that you're not supposed to do in Vulkan. So I'm delighted. I have that working now. Oh, and I do now actually announce which device ultimately got selected, because device selection kind of happens after these are printed, and I didn't really want to do a lot of duplicate work over and over again. I just print the devices first, and then I do the scoring, and then I will actually announce what device won on top, basically. This will be overwritable in the future, more than likely. Like, I'll make some sort of UI thing so you can switch, like, explicitly decide which device you want to use. But by default, I am going to pick the strongest one on the system, because this is, like, if I was doing a simpler Vulkan app that didn't need high compute capability, then it wouldn't really matter, and I would actually probably pick, like, middle of the road. Like, if there's an iGPU, I would prefer the iGPU in that case. But because this is supposed to be for games, I'm going to pick the DGPU, because that's probably going to be the best in the system. Yes, querying support. That should be in grading, I think. Yeah, grade physical device. We check a couple things. Device features. I think this was broken before, and I fixed it. When we're checking for support for certain things, I have to check, let's see. Oh yeah, sorry, I'm checking support for dynamic rendering and extended dynamic states. Now these, like, we passed the check before, I think, for some reason, because they weren't being queried properly at all, but I fixed it. It turns out I had forgotten to put S-types on my requests, which you really need to do, and I think Vulkan warned me about this after the fact, or something, but yeah. It was annoying, but it is now fixed, so we are so back. What else did I do? Yeah, we query support for these. There's support being queried for... Ah, yes, here we are. Wait, is this right? Please tell me I do have the latest. Okay, yes, I do. Whoops, did not mean to do that. What? There we are. This looks odd. I feel like I'm missing something here. Yeah, so we check the Q families, Q index. Ah, I think this happened somewhere else. Here we are in device creation. That's what it is. Yeah, in logical device creation. Is that where this was happening? Oh yeah, we need to extend create logical device. Yeah, so it happens over here. So this is kind of wordy. I'll full screen this for the time being. So what we do is a lot. Yeah, so I grab the actual Q family properties. So this will be, what's the best way to kind of describe this? Hello? Yeah, there we are. We can get various Q flat. Yeah, I think this is just a bit field of stuff. And yeah, we can check for all of these different bits. So like most important to us is the graphics bit. We want to make sure that our queue can, like whatever queue we're selecting actually supports graphics, because you don't want a queue that does like video encode. That's not particularly helpful to us right now. So we are checking that, but we're also checking specifically, does the physical device have support for surfaces? They do say in the docs, the chance of, yeah, here we are. It's actually possible, but very unlikely that the Q family's supporting graphics commands and the Q family supporting presentation do not overlap. But for simplicity, we assume there is such a Q family and bail out in case there isn't. Yeah, so we need to make sure that whatever device queue, or yeah, whatever device queue that we do select is something that both supports the graphics bit, like supports rendering graphics and supports surfaces is all good. Cool. Do you have middle mouse disabled? Because disabling middle mouse paste means to not expose that protocol. There is no config option. It's just whether it's present or not decides whether the client should use that behavior. So specifically what I have disabled is middle click paste selected text. I don't see any way of like disabling that being exposed. I feel like if I do this, like I'm just asking for trouble. The system must be restarted for that. No thanks. Oh, you're talking to Artsander about that. Yeah, that's fair. Cool. Yeah. So we have actually done swap surface creation. So we have that. Now we need to build our swap chain. So we're gonna do that. Let's get right into building the swap chain, because that's gonna be fun. Creating the presentation queue. Oh yes, I don't think I actually do this yet, so we do need to make sure that's done. The one thing that remains is modifying the logical device creation procedure to create the queue and retrieve the Vulkan queue handle. We need to modify the filtering logic to find the best queue families to use as we detect them. Cool. Let's just quickly make sure in app states that we do... Yeah, we do have graphics queue. Do I do this already, I wonder? Get device queue. It's possible that I do already, but I don't recall writing this stuff. Query for features. Oh, is this just like the full flow? I think it is. Yeah. We check all of that stuff. That's fine. Yeah. Query for Vulkan 1.3 features. We do that. We do that in grading, actually. So that's like already been done for us. So we don't really have to worry about that in logical device. We did that up front. And then we actually create the device. Yep. Oh, and then, yeah, literally just the last line there is we just like attach the queue. So yeah, no, we have actually Gauss in our device queue. So that's all fine. Now, swap chains. That'll be fun. Vulkan does not have the concept of a default frame buffer. Hence, it requires an infrastructure that will own the buffers we will render to before we visualize them on the screen. This infrastructure is known as the swap chain and must be created explicitly in Vulkan. The swap chain is essentially a queue of images that are waiting to be presented to the screen. Our application will acquire such an image to draw to it, and then return it to the queue. How exactly the queue works and the conditions for presenting an image from the queue depend on how the swap chain is set up. However, the general purpose of the swap chain is to synchronize the presentation of images with the refresh rate of the screen. Yes. Out of curiosity, how is text size for y'all? Because I know that's probably kind of small, but if I zoom it in, like, we get this stupid annoying padding. So I'll probably make it like this. This is probably readable. It's about kind of the same size as my editor text, which I think should be a good enough size for y'all. But do let me know if it's too small and hard to read. Maybe a bit smaller? You want it smaller than this? Fascinating. Checking for swap chain support. Not all graphics cards are capable of presenting images directly to a screen for various regions. For example, because they are designed for servers and don't have any display outputs. Secondly, since image presentation is heavily tied into the Windows system and the services associated with Windows, it is not part of the Vulkan core. You have to enable the VKKHR swap chain device extension after querying for its support. Which I do right here. And required device extensions. I got a whole thing over here. Yeah, we check to make sure that all of these are supported, and if not, then we will warn, hey, device doesn't support the required extensions, and then we early bail out and say, yeah, no. This is in, yeah, device grading, so we definitely know at this point that we support swap chains. You are now just checking to see if it's supported. We already do that. We're not going to bother. Yeah, we literally did this already. Weird that I'm being asked to do this a second time, because I wouldn't have put that in myself without being asked, I feel, but sure. Not a lot of words were visible and the words felt excessively large. I'm very confused by that. Alright, enabling device extensions. We do this as well. What is happening? Required device extension. Yeah, do we not pass that through and create the logical device? That'll be in create info, enable device extensions, which copies from required device extensions and throws on the portability subsets if applicable. Yeah, no, we do this, so we can skip a lot of these details. Querying the details of swap chain support. Just checking if a swap chain is available is not enough because it may not be compatible with our Windows Surface. Creating a swap chain also involves a lot more settings than instance and device creation, so we need to query for some details before we're able to proceed. There are basically three kinds of properties we need to check. Basic surface capabilities, the min and max number of images on the swap chain, and the minimum, maximum width and height of images. Surface formats, be it pixel format and color space, and available presentation modes. The section covers how to query the structs that include this information. The meaning of these structs and exactly which data they contain is discussed in the next section. Let's start with basic capabilities. These properties are straightforward to query and are returned into a single VK surface capabilities KHR struct. Cool, so I guess we just start now. Cool, and we'll be able to create swap chain. Yeah, they put spaces between. Yeah. Cool. Now we actually need our function for the swap chain. Let's just go up here and just kind of like steal the function signature because it's going to be the same anyways. Cool. Create swap chain. We will return SL error OK. Fantastic. I'm going to move create surface up actually because that does get called earlier. Yeah, that'll get called right after create instance because that's when it actually executes. Create swap chain. Let's have a gander. Surface capabilities. VK surface capabilities. KHR is... Oh, wait. We'll do this. And... yeah, surface capabilities. Oh, not an S-type. Sure. Okay. VK get surface... physical device surface capabilities? Oh, so it is. Physical device. We will grab our VK surface and surface capabilities. That is a long function signature. All good though. Can this error? This can error. So we will VK result equals that, and if result is, we're just gonna copy this here because that makes my life a little easier. If it's not VK success, failed to query physical device surface capabilities. And then we just error out nice and early. Surface capabilities. We need to check a couple things. We need to get formats. Sure, I guess we just get them all at once, right? Mm-hmm. And this is probably going to be almost identical code. Yep. And surface formats. Oh, whoops. I say surface twice. You are unhappy with this. Why? P surface format count. Oh, shoot, it's an array. Okay. So, N surface formats. We'll start with this. That's all fine and well. And then assuming that passes, then we can do good old SDL malloc. And we're going to do size of VK surface formats KHR times N surface formats. Why are you unhappy? You are not a pointer. That would make sense. Awesome. And then we pull that again. We swap out the null with surface formats. We're gonna probably want to call it that. Fantastic. That's wordy, but yeah. Query surface capabilities. Query surface formats. What if it's VK result? Julia, I'm throwing you against the wall. You are exploding. Also, my cat wants to leave. One moment. The cat is gone. Sorry for everyone who wanted the cat. Right. We get our formats, and now we need present modes, which is, again, a fucking vector. That's delightful. So we have to do, like, all of this stupid shit again. I think I should write abstractions for this. This is so wordy. We are going to do this. Let's do VK surface format KHR. Surface formats. Oh, whoops. SL Vulkan. Query. Get physical physical device surface formats. And in this case, we need to provide an app state app. Nah, we'll do it this way. VK physical device, and VK surface, KHR surface, and UINT 32T and surface formats. Cool. And then we dump that in here. Delightful. Remove these app prefixes. Oh, app VK prefixes. Oh, right, because these are technically already like numeric handles, so we don't have to deal with that. And that's fine, and that's fine, and this gets replaced to that. Apologies, I'm just kind of like running through shit. I have had to write an abstraction of this exact nature like a couple times already. It is basically just wrapping this in a nice little function so that all I have to do is grab you and you. SL Vulkan get all of this, and that will be app physical device. We'll drop a line down here. App, oh, whoops. That needs to be a VK. And then end surface formats. And there we go. That's the entire call, which is much easier to read, I think. And then all we have to do is a null check, basically. Yeah, and this part's like even easier. Because here, all we need to do, because we've already printed the error, assuming we had a problem. So we'll just check if it's null, and then we bail. So really saves on the line counts, because otherwise that would be like a massive pain in the ass. And we're going to do the exact same thing with, what are we doing? Present modes. Query present modes. VK present mode. Yeah. That should just work, right? Probably. And we'll just create something again with the same function signature. In fact, it's going to be virtually the same goddamn function. We're just going to change exactly what it grabs. VK present mode. Yep. Whoops. I went a little overkill with that. Cool. Wonderful. VK present mode KHR. Surface formats. Yeah, that's fine. Yeah, and we'll just slap that in there too. Fail to query number of physical device surface present modes. Long ass function signature. Monka. But we do get them. So that's nice. Nice and easy. Choosing the right settings for the swap chain. It's funny because this is literally a one-liner in C++, but because we're not doing C++, we're doing C, we have to do all of this crazy shit that I've compacted into 4 lines, but ultimately calls to, like, nearly 20 full lines of code. It's not ideal, which is why I'm saying, like, when I'm done doing this in C, when I've done all of the, like, big low-level learning stuff, I want to switch to Rust because Rust is going to give me like so much of this error checking like way easier, and it does actually, you know, we have array support, we have vector support in Rust, which is going to make my life a lot fucking easier. I don't have to do this stupid like allocate, you know, pointer shit manually. She loves me. She's going to write an engine and Rust together. Yeah. Can two wives make an indie game together? I say fuck yes. And it's actually based and awesome. I want to see you bang your little head. Oh, I read that wrong. I want to see you bang your head on the borrow checker. I already have a bunch of times. Like, I've written in Rust before, and I'm a lot better at using it than I used to be. And a lot of what I'm doing here isn't like super complex memory management. A lot of the stuff that I allocate, I get rid of by the end. Like, most of the mallocs that I'm doing is literally just for checking for device support, and then I discard the information. The only things that I actually store long-term are in here. I store some Vulkan context things, and by the way, most of these are just like ints under the hood, because they're like basically like abstracted pointers. Like VK instance is a handle. Like, that's it. There's not that much to it. So there isn't a crazy amount that I actually need to store. But chances are Rust won't like that model, and we'll probably have a very different API, but I'll be able to work with it. I have actually done a Vulkan project in Rust before. It's the first time I learned Vulkan was actually in Rust. I just didn't really learn Vulkan. I went through the process to draw a triangle, but I didn't really understand what I was doing. These days, I actually know what I'm doing. So I expect it to be a lot more exciting and fruitful. I will teach her to understand the borrow checker heart. I believe she will, actually, because she's like, whereas I'm crazy for C memory management, she's crazy for like Rust borrow checker. Something I want to do here, actually, before I forget, is I need to free surface formats and present modes, because I discard that memory after. Right, so you have our present modes. Choosing the right settings for the swap chain. There may still be many different modes of varying optimality in the swap chain. We'll now write a couple of functions to find the right settings for the best possible swap chain. There are 3 types of settings to determine: the surface format, color depth, presentation mode, conditions for swapping images to the screen, and swap extent, the resolution of images in the swap chain. For each of these settings, we'll have an ideal value in mind that we'll go with if it's available, and otherwise we'll create some logic to find the next best thing. Surface formats. The function for this setting starts out like this. We'll later pass the formats member of the swap chain support detail struct as an argument. Okay. So choose swap surface formats. Takes in as arguments the vector. Wait. Oh. Okay, it takes in a const vector pointer. Wait, what? Why is the const after? That part's a little confusing. We take in a list of available formats. We return? Oh, so we give it the list of formats supported, and then we return the best one out of the list. Okay, we just assert it's not empty, and then return the first. Yeah. I mean, I guess. Okay. SL Vulkan, select swap surface formats. Cool. That actually returns an int. Wait, no, sorry. This function doesn't exist yet. I don't know why it's even saying it returns an int, because it doesn't exist. What are we going to need to throw into here? I guess just our existing list of surface formats. So let's do... You know, I probably don't need to do it this way, thinking of it. We'll do this. And then for UN32T... Actually, yeah. We need to assert that it's not empty. Is there an assert in C? I don't know. We're gonna find out. Oh, come on. Yeah, we don't have asserts. Oh, we do in assert.h. Oh, for fuck. There we are. That's better. We're cert that it's not empty. So yeah, greater than 0. That would be fine. We do this, and for... We seem to just pick the first one, actually. Each VK surface format KHR entry contains a format and a color space member. The format member specifies the color channels and types. For example, VK format EBHGHR8A8S RGB means we store the B, G, R, and alpha channels in that order with an 8-bit unsigned integer for a total of 32 bits per pixel. The color space member indicates if the sRGB color space is supported or not using the VK color space KHR sRGB nonlinear flag. Okay. For the color space, we'll use sRGB if it's available because it results in much more accurate perceived colors. It's also pretty much the standard color space for images, like the textures we'll use later on. Because of that, we should also use an sRGB color format, of which the most common ones is VK format EBAG8R8A8 sRGB. Let's go through the list and see if the combination is available. Yes, so we will go to surface formats I dot, we check if the format is VK format HRGB. Oh, come on. Probably not going to want to do it that way. That's going to be BAG8R8A8 sRGB. We'll check if it's not equal and then continue if not. And then surface format equals surface formats I and break, because we've already found one that's a good contender for us. Why is this unhappy? Uh-huh. Huh. Do you need to... I guess I do. Interesting. Yeah. Format IT? Format it? What? Find if from available formats, which was this. Yeah, so that's surface formats. If for each format, return format.format equals that. Oh, and the color space. Yeah. And in this case, we're looking for VK color space sRGB nonlinear KHR. Yep. So we check to make sure those are all equal. And that's good. If that fails, then we could start ranking the available formats based on how good they are. But in most cases, it's okay to just settle with the first format that is specified. Yeah. Oh, that's if it completely fails. Yeah. So if surface format is somehow null, then we will just pick the first one. In fact, we can just do that by default. Because it'll be reassigned here if we have the ability to do so, at all. So I think that's fine. Alright, I am fearfully announcing the birth of the doodle in real life. That is horrifying. Please keep me posted. If something abort one, true. In fact, yeah, I don't really like this asserts, to be honest. We are going to SL error That's already an unsupported error. It's more of a Vulkan error. No available surface formats could be found. And we don't really have an error there. That's just like, yeah, we didn't have any. So if n surface formats equals 0, then yeah, we just early bail and it's over. Check live on melody chord. Uh-oh. Oh no. Hold on, y'all can hear that. How much of this can I... You know, I'll just download the video. This is fine. It's never been more fucking over than it is right now. Horrifying. Thank you for sharing. Oh, I just saw this. Graphic stuff is particularly awful to do with a solid memory ownership model. I recall it being feasible, though. Like, considering it was one of the earlier projects I had done in Rust, like, it was doable, and I was able to navigate it. Even if I didn't fully understand it, it was navigable. And the API is probably, if it's changed at all, is probably only improved. I think I'll be okay. I'm crazy for type provariance and memory safety. Do you mean type provenance? I think is what you're referring to. I'm not entirely sure though. Cool. So now we select surface format based on that. And we could even then wrap this in like yet another wrapper if we wanted to. That is possible. We don't want to free surface formats right now. We want to actually like select what we're going to use first. And like create our swap chain based on that. Provenance, yeah. Basically the proofs that types are what they say they are. Yes, yes, I love that. Presentation mode. The presentation mode is arguably the most important setting for the swap chain because it represents the actual conditions for showing images to the screen. There are 4 possible modes available in Vulkan. Immediate. Images submitted by your application are transferred to the screen right away, which may result in tearing. Not in Wayland, but yes, yes. FIFO. The swap chain is a queue where the display takes an image from the front of the queue when the display is refreshed, and the program inserts rendered images at the back of the queue. If the queue is full, then the program has to wait. This is most similar to vertical sync as found in modern games. The moment that the display is refreshed is known as the vertical blank. FIFO relaxed. This mode only differs from the previous one if the application is late and the queue was empty at the last vertical blank. Instead of waiting for the next vertical blank, the image is transferred right away when it finally arrives. This may result in visible tearing. We're probably going to ignore this one. FIFO looks the best right now. E-mailbox. There's another variation of the second mode. Instead of blocking the application when the queue is full, the images that are already queued are simply replaced with the newer ones. Huh. This mode can be used to render frames as fast as possible while still avoiding tearing, resulting in fewer latency issues than standard vertical sync. This is commonly known as triple buffering, although the existence of 3 buffers alone does not necessarily mean that the frame rate is unlocked. If I recall correctly... Oh yeah, fewer latency issues. I could have sworn triple buffering gave more latency, but maybe I'm wrong. Only the VK present mode, eFIFO mode, is guaranteed to be available, so we'll again have to write a function that looks for the best mode that is available. Yep. We're gonna copy a lot of code here because these are very, very similar processes. For ramped, nice. VK present mode. Cool. Yep. Cool. And we're going to have different if checks in here. because we have different parameters here. Is this literally just like an enum? It is. Fantastic. That's great. It's a little easy to check. And present modes. And we just check if it is VK present mode FIFO KHR. Cool, great. I think the VK present mode KHR email box is a very nice trade-off if energy usage is not a concern. It allows us to avoid tearing while still maintaining fairly low latency by rendering new images that are as up-to-date as possible right until the vertical blank. On mobile devices where energy usage is more important, you will probably want to use VK present mode KHR eFIFO instead. Now let's look through the list to see if mailbox is available. Fucking holy C++, what the hell? Okay. Okay, so we assert that we have at least a FIFO one, and then we return any of having mailbox or FIFO. Okay. Understood, understood. Okay. I feel like FIFO will be fine, but for the sake of, you know, following along, we are going to do this. And then we'll just early break. And failing that, we will get the first one that has this mode. Yeah. So we prioritize mailbox, but failing that, we will look for the first one that has FIFO. Cool. Technically, that's not exactly what this does. If it stumbles upon a FIFO one before a mailbox one, then it's going to return the FIFO one, but it's fine. I think it's more of that one Top Gear meme. This is brilliant, but I like this. True. We're guaranteed to at least have a 0 here, but I think I'm going to make this null. And if we cannot find one, we do assert to make sure there is at least a FIFO one available. So we are going to check if present mode is null and no suitable surface presentation mode could be found. Different error. Cool. And yeah, cool. So we choose our mode. That leaves only one major property, for which we'll add one last function, choosing the swap extent. Cool. Weird that we got surface... Yeah, okay, that's when surface capabilities comes in. We're gonna put this here, because they, for some reason, put that at the end. So, yeah, we'll do that. Surface capabilities dot... Okay. Yeah, it's just one set of capabilities. The swap extent is the resolution of the swap chain images, and it's almost always exactly equal to the resolution of the window that we're drawing to in pixels. More on that in a moment. The range of the possible resolutions is defined in the VK surface capabilities KHR structure. Vulkan tells us to match the resolution of the window by setting the width and height in the current extent member. Okay. However, some window managers do allow us to differ here, and this is indicated by setting the width and height in our in current extent to a special value, the maximum value of uint32t. In that case, we'll pick the resolution that best matches the window within the min image extent and max image extent bounds. We must specify the resolution in the correct unit. JLFW uses 2 units when measuring pixels, measuring sizes, pixels and screen coordinates. For example, the resolution with heights that we specified earlier in creating the window is measured in screen coordinates, but Vulkan works with pixels, so the swap chain extent must be specified in pixels as well. Unfortunately, if you're using a high DPI display like Apple's Retina display, screen coordinates don't correspond to pixels. Or, and I believe this is the case, if I were to change this monitor to use like 200% scaling or something like that, it would be a fairly different story. Instead, oh, here. So if Vulkan doesn't fit the swap extent for us, we can't just use the original width height. Instead, we must use GLFW get frame buffer size to query the resolution of the window in pixels before matching against the minimum and maximum image extent. Cool. We're going to do that slightly differently because we are in SDL, but... okay, not give me a lot here. Is there window extent? What would it be here? Frame buffer size. Probably just SDL.h, right? That might have it. Not giving me a whole lot here, guys. Okay, hold on. Let's peek in here. Nothing for size. Lots of things referring to the window. Bulk create surface. Load library. There's not a whole lot in here. Oh, that is in the Vulkan file, though. Hold on. Let's try SDLH. Ooh, good heavens. Could be under video. Get window display scale. So, gets the content display scale relative to a window's pixel size. I don't think that's what we're looking for. That's getting a scale as a float. We want get window size. Okay, yeah, that does exist. And it gives us a... Okay. Yeah. Window size in pixels. Is that specifically what I'm getting? Yes. So you actually want to get window size in pixels. That's what we're looking for. Perfect. Cool. Great. We could then do app SDL window. And we're going to just have an int width, int height. We're going to make these both 0 to start with. Fantastic. In fact, VK extends 2D. We're gonna be fancy with it. Passing UN32T. I'm sure it'll live. I'm sure it'll live. Yeah, relax. You're fine. Cool. Get the window size. You know, I should probably work on my own project while watching. Entirely up to you. Okay. Oh yeah, where's that maximum thing that they were talking about? I didn't fully register that. Some window managers do allow us to differ. Tells us to match the resolution of the window by setting the width and height of the current extent member. Okay. Right. Okay, okay. So if surface capabilities, current extent, width equals uint 32 max. Uh-huh. Or we do this. I see. I see. Okay, okay. This is fine, actually. So we will actually do this. And once we have those collected, then not STD clamp. There's got to be just like a clamp function. For God's sake. What? Isn't clamp a thing? What do you mean? Maybe this has it. I'm pretty sure that's just for floating point math, but we can have a look. GLM clamp, yeah, that's for floats. Not helpful. There has to be a C clamp. Why don't I see it? Okay, not even close. Okay, basically write your own. That's so helpful. No free lunch in C, everyone. You just gotta make your own. Let's go! So, like... do that. If and def. And if. And we're gonna do int. Yeah. Int a, int min, int max. I'm just gonna like write a stupid, oh wait, hold on. Probably want to be doing this over in math.c. I'm gonna write like stupid simple and then I'll like see what I can do to simplify it. If a is less than min, then we return min. If a is greater than max, we return max, or we return a because it's in the middle. That seems reasonable. I don't know if they care about it being inclusive or not, but I suppose we'll find out the hard way at some point. Cool. Okay. Extent.width equals width clamped between, I can probably close that now. Tell you what I'm gonna do real quick, because, yeah. Get rid of these, get rid of those, because that's a lot of writing. Capabilities, min image extent width, and capabilities max image extent width. Good grief. There we are. Good enough. Ah yes, open project from yesterday. Discover new double free issue in my code. Let's go! I'm thankful my biggest issue hasn't been double freeing. It has been not freeing at all. Remembering to put those in is nice. Thankfully, the way that I... What was I going to say? I've already forgotten. That's crazy. Oh yeah, thankfully, the kind of stuff that I'm doing right now, it's a single allocation. So like, it's a memory leak, but it's just like one block of extra memory that just sits there. it's not gonna like pile up over the lifespan of the program necessarily. Well, okay, if I were to like change resolutions or like change graphics in some radical way, like yes, okay, there'd be something more involved, but you know, not the end of the world. Right. Creating the swap chain. Now that we have all of these helper functions helping us with the choices we have to make at runtime, we finally have all the information necessary to create a working swap chain. Delightful. Create swap chain function that starts at, well, I've already kind of done that. What was all that about then? If not part of that. Oh, well, I guess, yeah, these were all supposed to be in like their own functions, weren't they? Yeah, something like that. So like in total, you're checking for support and then querying details, which shows surface capabilities, surface formats, and presentation modes. Yeah. I could probably shove these into their own functions. Maybe. Gotta think about this. Because there's a malloc happening here. So I have to free the actual, like, lists that are allocated here. So, like, maybe the best way to go about this would be when I have my surface format, I just malloc it again, free the array, so that I'm only returning the one thing that could just be freed later. Maybe. And that would include all of this extra logic here as well, for what it's worth. Let's see. Means I can get rid of end surface formats. Yeah. All good. And ooh, what would be the best way to go about this? Yeah, here's what I'll do. Cool. So we malloc one of them, and then if it works, then surface format color space is surface formats I color space, and we pull in the formats as well. Cool. And then we just return the one that we've got. Cool. And then we could just free it after. So we will have all of that then. Yeah, and that like really simplifies this. Cool. Yeah, that does simplify things a little bit. And we'll go over here as well to get our presentation mode. And we're going to do a lot of the same thing. Whoops. Oh, shit. Here we are. I want to take this and paste it here, and that needs to be initialized to 0. And there we go. Pass in his pointer. Remove that dereference. Present mode equals null. Actually, yeah, I don't think this even has to be a pointer, because it's like, present mode is like a fixed thing, so that's actually fine. Yeah. And just for the hell of it, we will really make sure it's actually prioritizing mailbox by just iterating through the list twice. We scan for mailbox first, and failing that, we'll scan for FIFO. Cool. So now we do this, and we do this, and we rename this function because it's not returning a plural number of these now. Let's fix the ungodly length of this function signature, or line length at least. Wonderful. And yeah, we can error Vulkan if that fails. Why are you unhappy? Ah. Oh, right, returning null is like a whole thing. -1, maybe? I think that'll work. Oh, that's fine. Don't need to worry about that. And we'll SL error here. Yeah, no suitable surface presentation mode could be found. And then we just error Vulkan. Lovely. And present mode is just an enum, so we actually don't need to do a free there anymore, which is wonderful. And as for service capabilities, well, in this case, we're just getting like the extent. Yeah. VK extent 2D, SL Vulkan gets... What did you call this function? Because I feel like I'm gonna like whatever they got here. Select swap extents. And that's going to take in VK surface capabilities KHR. Capabilities, we will accept a pointer to that. And then do that. There we go. Okay, window size and pixels. Ah, yeah, probably gonna need the window size. SDL window. And then we could just ask for those. Fantastic. Return extents. That's, yeah, we can probably just do like return the current extents. And then in this event, do that. And then this doesn't actually have to be an else anymore. This can just be the base case. Cool. I love a nice early return. Notice something odd in SDL. To destroy audio, you call mix destroy audio. To destroy texture, you call SDL destroy texture. To destroy a font, you call TTF close font. Why is it close? Font file would be my guess. That's probably what it does under the hood, if I had to guess. Cool. And then we pass in our capabilities, and then we pass in app SCL window. Is that already a pointer? It is. Cool. So we have our extent. In fact, let's quickly run a check here. We have 13 mallocs. We have 14 frees. Oh, well, I guess there are some cases where you will need to free in like multiple different cases here. It's kind of weird. But yeah. There's probably a slightly better way I could do that, but it's probably fine. I'm probably freeing responsibly. It's probably okay. Cool. Now, creating the swap chain. Now that we have all of these helper functions helping us with the choices we have to make at runtime, we finally have all the information necessary to create the working swap chain. Oh, yes, we have all of this now. We have our surface capabilities. We have our swap chain extent. Oh yeah, minimum image counts. That's going to be pretty easy. To swap min image counts. Where was that done? That seemed to have just been like missed here. Oh, no, here it is. Lol. Min image counts, cool. Our available formats we pulled from here. And then swap chain surface formats. Yeah. Yeah. Then we get our extent, then our min image counts. Cool, and that's just UN32T. We'll start with 0. And then over here. Oh, well, I suppose we should start with capabilities, min image counts. That would make sense. Oh, aside from these properties, we also have to decide how many images we would like to have in the swap chain. The implementation specifies the minimum number that it requires to function. However, simply sticking to this minimum means that we may sometimes have to wait on the driver to complete internal operations before we can acquire another image to render to. Therefore, it is recommended to request at least one image more than the minimum. Like that. I suppose there's no higher limits? I could have sworn there was a capabilities max image counts. Yes, there is. We should also make sure not to exceed the maximum number of images. Okay. Let's do the maximum. God damn it. I could probably stitch the min and maxes together, can't I? I think that's how that works. You know, I don't feel like writing that right now. I just kind of want to get this working. I can optimize it later. So we'll pick the maximum as soon as I have math.h exporting this function. And max. Yeah. So the max between that and max image counts. What the hell? trying to read this. That's so weird. I'm gonna do like... No, I want that. And then... No, okay, hold on. I'm getting confused. We're gonna do this for now, and we're probably just gonna leave it as such, and we'll see what happens. As is tradition with Vulkan objects, creating the swap chain object requires filling in a large structure. To be fair, the swap chain is a fairly complex object, so is among the larger create info structures in Vulkan. Yep. VK swap chain create info KHR. Create info is going to be 0 initialized. And then create info.s type needs to be swap chain create info. What else do we need? We need a surface, and which we have. It is app vk surface. We also need min image count, which is min image count, if you'd believe it. Create info image format is going to be surface format. Surface format dot format. Image color space is going to be that. Create info dot image extent is going to be extent. Create info image array layers 1. I'm sure we'll figure out what the hell that is later. Create info image usage. VK image usage flag bits. E color attachments. Sure. I guess we are attaching color to the swap chain. That makes sense. What are the other options for this? Fragment shading rate, attachment feedback loop, depth stencil, input attachment. Okay. Lots of shit. Lots of other shit you could do. Tensor aliasing. We're just doing color. We're just doing color today. Image sharing mode. I'm probably freeing, okay? Famous last words. True. VK sharing mode exclusive. What are the others? Concurrent and maxenum. Sure. Yeah, VK sharing mode exclusive. Pre-transform is going to be capabilities current transform. I think we can, yeah, we could free surface format pretty soon after this. That's fine. In fact, you know, I'm not going to bother making it a pointer. Shit, I need to make it a pointer. No, I don't. This can be SLR. And we can take in as a pointer a VK surface format KHR formats. Yeah, that's all fine. SLR okay. So the idea... Oh, yeah. No, this is actually perfectly fine. Yes. Everything else can kind of remain the same here. We don't need to do the malloc anymore, though. In fact, let's remove these, because because this is just like stupid hard to read. Just format is fine. I should install Fedora or something. I recommend it. It's nice. I've been enjoying Fedora. It has been a very nice and stable experience for me. Oh, and we are dark mode. It's that time. That should actually mean that now this screen has now changed. Yep. That's fun. It is now dark theme. Funny watching that transition. Anyways. Cool. So now we don't have a pointer to free anymore. So we can just do this. And we can, if that, if it is not okay, then we return SL error Vulkan. Actually, SL error results can be this. And then we can do if results is not equal SL error okay. And then we just return whatever the result was. That function should probably have final say on that. Fantastic. Can this error? This can most certainly error, so we are going to change this as well. VK present mode KHR mode. Cool. Awesome. And here we will set present mode. Oh yeah, there's a malloc in there. SDL free present modes. Yeah. And then present mode can just be equal to that. Why doesn't it like this? Does that have to be dereferenced? Ah, right. We dereference and then assign it, I believe. Yeah. Lovely. Can remove the unnecessary braces here. We tidy that up. And oh yeah, sorry, I do actually need brackets here, I think. I don't think I need it here. A little awkward, but like doable. Yeah, like that. That's okay. Actually, wait. What am I doing? I don't have to do a malloc at all. Delightful. I much prefer this method. I should see how many mallocs I'm doing where I don't actually need to malloc and I could easily just stack allocate. Yeah, like this, I don't return the list of formats. So I can probably just do formats size to n formats. Yeah? Okay. I am very down for us doing less mallocs. It's cheaper for us to do so. And then we do pretty much the same thing here. Fantastic. Oh, right. There's another result here. That's fine. Lovely. You love to see it. SDL Malak. Let's see what other Malaks I'm doing that I don't actually need to do. This does return the list. That's fine. Extensions. This returns the list. Required layers. Required layers. Where are you freed? Ooh, do I not free you? I hope I free you. Yeah. What? What's going on here? Oh, God damn it. There. Happy. Good grief. Actually, wait. Yeah, I could probably just, what's your deal? Okay, so it's... Are you still being weird? Required layers. Hold on. Okay, yeah, no, it is just being weird. We're gonna ignore it then. Yep, that's fine. We're just gonna ignore it. And as for freeing VK layers, where do you come from? You actually return the layers, that's fine. SDL Malik, let's just check other cases of this. Do we return instance extensions? I don't think we ever return it or free it. So we definitely need to make sure we're not doing that, I think. Leave the object uninitialized. Can I do this? No, it hates that. Default initialization. Or like, what do you want me to do exactly? Leaves it uninitialized. I do a mem copy like immediately after, bro. Okay, so that's really weird. I don't really get the point of that. How are you supposed to do this? Variable-sized object may not be initialized. But if I did this, it would be fine. Oh, of course it would. Okay, maybe that's what I have to do. Let's mem set. It's still complaining it's uninitialized. That's so annoying. It's actually annoyed me so much, I am just going to, like, leave it mallocked. I'm so against having these. Okay, instance extensions. When is the last occurrence of this being used ever? Oh, wait, we do free instance extensions. Okay. Well, that's fine. Required layers. Yeah. Thought I'd mix something up there. Okay. That's fine. Instance extension, that's been checked. That's fine. Physical devices, we do return that, but let's make sure we're actually cleaning it up after. That returns physical devices, which we never freed. Bad. Very big bad. Okay. Yeah. We malloc that and then pass it through. When can we get rid of it? Get physical device properties. Okay, well at this point the device has been selected. Right? Physical devices, we iterate through there. Yup. Uh-huh. Cool. I can probably free it then. Cool. Physical devices, that does get freed eventually now. Q families. We free it literally right down here. I can see it. VK device extensions. Anyways, is this something that Valgrind can point out for me? Like a memory that's been freed without ever getting mallocked during the runtime? I feel like that should be a thing. Device extensions. Interesting. Oh, that's just the end of the... Yeah, sure. That's fine. Just that doesn't confuse me. VK device extensions. Do we free you? We do. Good. Another malloc. Q families. Do we free Q families? We do indeed free Q families. Do we free extensions? Very soon after. Do we free enabled device extensions? We do. Delightful. So there are 9 mallocs. We've reduced it kind of dramatically. And we have arguably more frees than we actually need. I am going to tidy this up too. I feel like it. And I have a way that I can do this. This returns an int, yeah? It does. Cool. So we can reduce the number of calls to free that we have in the code by just doing the check here. Like so. Wonderful. We can do the same over here. Lovely. Required extension supported. And we'll put that down there and this over here. Lovely. Let's check out our other frees. Cool. We once again do this, but Q families is like already very much been used. We don't have to look anymore, so that's all fine. Free device extensions. Yeah, we've got like an early return here. What are the chances I can get away with doing this? Okay. Does that then... We're literally just checking to make sure if it's supported and then we return a score. Yeah, okay, sweet. Yep, cool. We can just leave that fall off the stack. That's okay. Q families, I can probably do a very similar thing here. If I had to guess. Yes, I can. No Malik, no free. Love it. Love it, love it, love it. I definitely got a little bit too happy with my Maliks, but that is okay. We are addressing this. This is one of those weirder cases, though. I don't know, we could probably... If we took it out of the function, we wouldn't need to do a Malik at all. But also kind of a pain in the ass. Is it? Yeah, the function is already kind of long. I don't know. I don't know. We do free it. Like, we at least free it. It's responsible enough. Let's check our other Maliks just to make sure these actually needed. We return layers, that's important. We return extensions, so that's important. Instance extensions, right. We were getting weird fucking warnings about this not being initialized. I wonder if I just, like, write it again. Will I do a better job? It still warns about, like, not being initialized, which is really, really weird. Like, I can memset you if that's what you really want, but it doesn't seem to be making the compiler very happy. Yeah, I don't know what you want from me, bro. I've done what I can. Shit's just unhappy. Unfortunate. Oh, default consonant var unsafe. Is that why? Hold on. Ah. I see. I see. Okay. That's fine. Hey, it's not complaining elsewhere, so yeah, we're okay. Do we even need the memset anymore? I don't. I think we're okay. Sweet. Check for my other Maliks. Yeah, layers is fine. Extensions is fine enough. Physical devices. Yup. Q families. Let's see if we even need this. I'm gonna assume we don't return this later, so a free is completely unnecessary. It is indeed! How delightful. Another Malik. This is for our extensions. We don't pass this elsewhere, so we can just get rid of it after. No Malik needed. Enable device extensions. We can get rid of that too. And the memcopy still works. We can get rid of the free. We have 3 Maliks now in the entire thing here. And we have 4 frees. What's the extra free about? Let's look at this. We Malik layers and extensions, instance extensions in particular, and physical devices. Let's look at what we are freeing. Layers, Vulkan layers, that makes sense. Instance extensions, physical devices. Ah, we free Q families, but that's not an array anymore. Wonderful! I feel very good about this. Yeah, there are 4 Maliks now in, like, the entirety of my code. This is really good. Really, really, really good. For fun. We're gonna log H. And this will now just be a void in it. Because in main, the idea is that we have our logger. Actually, oh, right. Expected name is... Oh, right. And that can just be this. Destroy is probably not needed anymore because destroy just does a free. So we'll actually get rid of that altogether. Look at that. 3 Maliks. 3 frees. Beautiful. There used to be like 12. Remember, everyone, only Malik when you absolutely have to. Because it is more expensive, it makes the program slightly slower, and you risk forgetting to free your shit afterwards. Which is really bad. Okay, cool. I'm very, very happy with that tidy up. Took a huge detour to do it, but we have done it. And I feel very, very good about that. What else do I need to do? Pre-transform, composite alpha. I'm going to need that. VK composite alpha. Oh, come on. Composite alpha flag bits. E opaque. Sure thing. Present mode. Pretty sure, yeah, I've got my present mode already. Perfect. And create info clipped equals true. Wonderful. And then just like image array layers is just hanging out there. Oh wait, we already... Oh, here. The image array layer specifies the number of layers each image consists of. This is always 1 unless you're developing a stereoscopic 3D application. That makes a lot of sense. Also good to know. Image usage, the color attachment. The image usage bit field specifies what kind of operations we'll use the images in the swap chain for. In this tutorial, we're going to render directly to them, which means they'll be used as color attachments. It is also possible that you'll render images to a separate image first to perform operations like post-processing. In that case, you may use a value like transfer destination instead, and use a memory operation to transfer the rendered image to a swap chain image. Interesting. The image sharing mode specifies how to handle swap chain images that might be used across multiple queue families. There are 2 ways to handle images that are accessed from multiple queues. Exclusive, an image is owned by one queue family at a time, and ownership must be explicitly transferred before using it in another queue family. This operation offers the best performance. And concurrent, images can be used across multiple queue families without explicit ownership transfers. We are using exclusive, probably makes things simpler. Yeah. If the queue families differ, then you could use the concurrence mode to avoid having to do the ownership chapters, because these involve some concepts that are better explained at a later time. Concurrent mode requires you to specify in advance between which queue families ownership will be shared during the queue family index count and PQ family indices parameters. Concurrence mode requires you to specify at least 2 distinct queue families. If the graphics queue family and presentation queue family are the same, which will be the case on most hardware, then we should stick to exclusive mode. Pre-transform, we have that set to current transform, yeah. We can specify that a certain transform should be applied to images in a swap chain if it is supported. Supported transforms in capabilities, like a 90-degree clockwise rotation or horizontal flip. To specify that, you do not want any transformation, simply specify the current transformation. Cool. And that would be, yeah, they're just like flag bits. Yeah, so if we wanted to flip for whatever reason, I guess we can do that. Can't think of many cases where we would want to do that, but we can do that. composite alpha. The composite alpha field specifies if the alpha channel should be used for blending with other windows in the window system. You'll almost always want to simply ignore the alpha channel, hence composite alpha flag bits KHR opaque. Yeah. Now, there's some very cool use cases for the alpha channel, but we're not going to need them. Cool to know, though. That is where I would be setting that. Present mode. Choose, yeah, we already have our present mode here, and that is mailbox or FIFO, if mailbox is not available. And clipped. The present mode member speaks for itself. If the clipped member is set to VK true, then that means we don't care about the color of pixels that are obscured. Also, yeah, I just realized. Probably want to be using that. Where am I even getting booleans from? Yeah, it's fine. Have booleans become a part of the C standard? Because I recall having to pull in a header file for this before. Or like just define my own like true and false constants. Oh yeah, standard bool. Had a feeling. I don't know why I just never complained about that. For the sake of like making sure it compiles properly though, I'm gonna leave it out. They have a newer standards. That might be it. I might have been using like C18 or older for all I know at the time. Okay. If the clipped member is set to VK true, that means we don't care about the color of pixels that are obscured. For example, because another window is in front of them. Sure. Unless you really need to be able to read these pixels back and get predictable results, you'll get the best performance by enabling clipping. Cool. Swap chain create info, old swap chain. Okay. That leaves one last field, old swap chain. With Vulkan, it's possible that your swap chain becomes invalid or unoptimized while... let me just set that to null now. While your application is running, for example, because the window was resized. In that case, the swap chain actually needs to be recreated from scratch, and a reference to the old one must be specified in this field. This is a complex topic that we'll learn more about in a future chapter. For now, we'll assume that we'll only ever create one swap chain. I am not going to do that because I know that's going to happen. My window is resizable. We're going to do VK swap chain, old swap chain, and that will be null by default. Let me quickly check. VK swap chain KHR, it's just a handle, so we'll just do that. Yeah, I definitely want that specified. We are going to do null for now, though, because, yeah, at the moment we currently don't do this, but it's going to be very important in the future that we can just recreate the swap chain very quickly when we need to. Also, keep in mind, that code that I just wrote, this runs every single time the window's resized. So if you ever wonder why a screen like has to blank out for a while sometimes when you're resizing, or like it takes a while, it stutters, it's because there's a lot of shit going on. C for anything. It's possible my compiler's using like C99, to be completely honest. Who knows? Okay. Yes, reference you'll must be specified in this field. Complex chapter we'll learn more about in a future chapter. For now, we'll assume that we'll only ever create one swap chain. Cool. Now add class members to store the swap chain object and its images. Yes, we already have, I think, app vk swap chain. We do. Creating the swap chain is now as simple as calling the constructor, which in this case will be... Cool. P create info, that's going to be create info. We have no allocator, and our swap chain will be app vk swap chain pointer. That's definitely going to have results. There's no way it doesn't, indeed. And do we have a vk result here? We do. If vk result is not vk success, then we will return, I guess, vk results. That's probably fine. Oh, no. We need SL error Vulkan. My bad. Let's check really quickly. Create device. I'll just copy what I've got here. And slap it on the end of create swap chain. Fail to create swap chain. Yeah. And in this case, we kind of already know what the error is, so we'll just return app failure. Like, we've already printed it, we don't have to do it a second time. And in fact, for create device, I think we do the same. Yeah, failed to create Vulkan device, so when I go down here, we don't need to echo that back either. It's kind of redundant. Physical device, I think, is the same story. Let's see. Yeah, I suppose there's like a whole bunch of things that could be echoed out by this. I will probably still ignore it though. Failed to create the Vulkan surface. Yeah, that's fine. Failed to create Vulkan instance. That, I think... Yeah, we literally have the exact same line again, but with less error detail. So we'll just get rid of it. Look at how much more simple this error handling code is becoming. It's already just this. In fact, we can simplify this even more, because now we don't even get, like, we don't store the return value. Look at that. 2 lines. We could make it 1, but I like dropping this down personally. Nice. Look at how tidy this is. I'm delighted. Fucking beautiful. Look at that. Just everything in a nice order. So pretty. We don't even need this anymore. Amazing. So we have swap chain creation. Let's make sure it actually works. It doesn't! And we do get some validation errors, which is good. That's actually very good. Those are things that we will want to check on. Cool. What do we get? It's actually when creating the swap chain. That's interesting. What do we do wrong? Ooh, width and height, which is outside the bounds returned by get physical device surface capabilities. Uh-huh. Yeah. So, yeah, that UN32 max thing. Huh. Interesting. That would have been returned by device surface capabilities. Get physical device surface capabilities KHR, yeah. Huh. Interesting. Okay, tell you what. I'm gonna go to the bathroom real quick, and then I will... Oh, wait, out of device memory. Holy shit, that's really bad. I probably specified, like... Yeah, that was way too big of an image. That's fine. Tell you what, I'm going to run to the bathroom, and I will be right back, and we will debug this. Just a moment. And if you haven't had water, by the way, you should definitely drink water, because water is good for you. Water break and bathroom break. Do whatever you want. All right, I am back. Right as the song ends. Beautiful. Let's keep going. Right. The clear head. Let's figure out exactly what's going on here. So yeah, we are specifying way too large of an image extent, and we need to figure out exactly why that is. And I would say the best place to start would probably be why is capability's current extent returning maximum. So let's do an SL log on this. Current extent, width equals something, height equals something else. Let's just see what it returns. Cool. Yep, that is way too many pixels. That is just so many goddamn pixels. Okay, so let's read this section properly. The swap extent is the resolution of the swatting images, and it's almost always exactly equal to the resolution of the window that we're drawing to in pixels. The range of the possible resolutions is defined in the surface capabilities KHR structure. Vulkan tells us to match the resolution of the window by setting the width and height in the current extent member. Yes. However, some window managers do allow us to differ here, and this is indicated by setting the width and height in current extent to a special value, the maximum value of uint32t. In that case, we'll pick the resolution that best matches the window within the min image extent and max image extent bounds. But we must specify the resolution in the correct units. So let's read this properly, because I must have done something wrong. Oh, for goodness sake. That's supposed to be a NOS equal. That's what the problem was. Let's try again. And it worked immediately. Go figure. Ain't that grace? All right. Sweet. Well, yeah, no big issue here. All right. So what is the swap then that we are getting back? Let's have a look at that real quick. Don't you love that? How like a single character typo can completely fuck the application? My favorite. All right. Let's see what we're actually getting. Oh yeah, 1280 by 720. That is exactly what I expect, because the window default width and height is specified somewhere. Yeah, SL default window width and SL default window height is 1280 by 720. Perfect. So that is exactly what I expect. Fan freaking tastic. And now we have a swap chain. So I'm very happy with this. Now, and we get no warnings, by the way, which is like so great. The validation layer has absolutely no complaints. We are doing everything by the book. Cool. Now run the application to ensure the swap chain is created successfully. If at this point you get an access violation error in VK swap chain, create swap chain KHR, or see a message like fail to find VK get into proc address, see the FAQ entry about the Steam overlay layer. Oh God, yeah. Try removing the swap chain create info.image extent line with validation layers enabled. You'll see that one of the validation layers immediately catches the mistake and a helpful message is printed. You know what? Let's do that. Let's do that for fun. Let's remove the extent altogether. And we do. Image extents width and height equals 0 is valid. They must both be non-zero. This specifically says it's not equal to current extent, which is interesting. So you got a slightly different error, but I suppose, yeah, it's invalid one way or the other, so it's fine. Mods, eat the swap chain. Hungry. Funny story that I have from like ages and ages ago. I was doing Java game development years ago. This was before I understood graphics APIs, so I would blitz the pixels manually to a buffer on the stack. No, it was Java. It was probably heap allocated somewhere, and I didn't really know good memory management back then. But yeah, I was manually blitzing the pixels to an array, and I had some horrible rendering bug, which you'd think would be easier to debug when you've got like a full oversight of how things render, but for some reason I just could not catch it. It was throwing me so badly, and it frustrated me so much I abandoned the project for like a month, and then I came back one day and I had another look and I found out it was a slight typo where I used an uppercase instead of a lowercase, and that's what caused the rendering issue. So I think the biggest long-term lesson I learned from that was name your variables better. If a simple like case issue was enough to completely destroy the functionality of your app, you need to seriously rethink how you're naming your variables. It's part of the reason why my variable names are like so much more verbose now. I only do like index being called I if it's like a really small loop and it's like super goddamn obvious what you're doing. I'll at least do like, I've got like an I_VK a couple times. That's about as vague as I get. Usually, especially with like stored data like min image count, I like to keep it really verbose because otherwise it tends to cause problems for me. And I don't like that. Right. Wow, I haven't had this one in a while. What the hell? Thanks, title mix. What the fuck? I'm watching a goddamn YouTube video from 2016. The swap chain has been created now, so all that remains is retrieving the handles of VK image objects it contains. We'll reference these during rendering operations in later chapters. Yes. One last thing. Store... Oh, wait, do we actually want to store that somewhere, I wonder? Store the format and extent we've chosen for the swap chain images in member variables. We'll need them in future chapters. Ah. Can do. So we have our swap chain. Yeah, swap chain images. Swap chain images and surface formats. That's fine. VK extent 2D is going to be swap chain extent. Cool. And we presumably store all of those right over here. We already store swap chain. So VK swap chain images is going to be Yeah. Huh? Oh, wait, it's probably VK get swap chain images KHR. Yep. We do that. App VK swap chain. The image count. I don't know. I guess min image count. And swap chain images. That's all fine. Can this error? It can error. So we do have to be mindful of this. Oh, image. Right. Right. How could I forget? Very important. Because we're in C. Okay, failed to get swap chain images. Cool. And surface format, we'll do app VK swap chain formats. I'll change surface formats to surface format. App VK swap chain extents. And that's not malloc, those are just consts, or not consts, they're on the stack and we're just doing a variable assignment, so it should be good. Surface format, similar deal. Beautiful, 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 beautiful. Validation error. Swap chain image count is null. Ah, whoops. Wait, what? Is that not supposed to be a pointer? P swap chain image count. Oh, did I goof? I did. My bad. My bad, slime. There we go. Perfect. And let's just verify at the end of the pipe here. I don't know why this is still highlighted. What? Okay, that was weird. Moving on. Create swap chain. Let's just verify some things. Make sure these actually, like, arrived on the other end. We'll do that. Think that'll be good. Cool. And yeah. And extents. All right, make sure that logs. Swap chain is 2 for some reason. Might need to double check that. Swap chain images is for some reason a null pointer. That doesn't seem right. Huh. It might just be like an ID for the swap chain, actually. Yeah. Weird. Weird. Yeah, I don't get that, but let's say it's fine. Let's say it's fine. We do have that, though. Swap chain extent is definitely correct, though, for what it's worth. We now have a set of images that can be drawn onto and can be presented to the window. The next chapter will begin to cover how we can set up the images as render targets. And then we start looking into the actual graphics pipeline and drawing commands. Lovely. Beautiful. Just make sure in app state, yeah, we have the swap chain. We have swap chain images, which in C I have to specify the length as well. We need the surface format, and we need the extents. Cool. That's all fine. Let's do it. To use any VK image, including those in the swap chain, in the render pipeline, we have to create an image view object. An image view is quite literally a view into an image. It describes how to access the image and which part of the image to access. For example, if it should be treated as a 2D texture depth texture without any MIP mapping levels. Okay. In this chapter, we'll write a create image views function that creates a basic image view for every image in the swap chain so that we can use them as color targets later on, which is this step. First, add a class member to store the image views in. That would be swap chain image views. Okay, uint32tn swap chain image views. Wordy. All good. Sweet. Now we have our create image views. Right. And we will copy and we will paste. Image views, and we don't need old swap chain in this one, so that's all good. Return SL error OK by default. Swell. The parameters for image view creation are specified in a image view create info structure. Of course they are. The view type, the formats, and the sub-resource range are identical for each of the image views. With the view type, we specify that we're rendering to a 2D screen. If we were wanting to render to a 3D screen, however that works, or cube map, those are also options, as is a 1D screen. Fuck it. Why not? As you can probably guess, we'd want a 2D render target in most cases when we're rendering to a screen. I mean, to be fair, a volumetric display would be cool, and it's nice to know that Vulkan at least supports it. I wonder, can you specify like arbitrary dimensions? Okay, they do have an enum for it, for what it's worth. Yeah. Next, we specify the image format. This is how the color space components are configured, so you get the right color format in your renders. Next, the components aren't needed for our swap chain. We'll talk about them in a bit, though. The last member is the sub-resource range, which is necessary, and we'll talk about shortly. Right. We assert the image views is already empty. Huh. Interesting. Yeah. It is just interesting, I guess. Sure. They put the assertion there, so I'm gonna double check that myself as well. I don't know, Vulkan error? Yeah. Sure, I guess. Okay. VK image view create info. Create info S type will be VK structure image view create info. View type is going to be VK image view type 2D. The format is going to be swap chain surface format. dot format. And create info sub resource range is going to be interesting. What are you? You're a VK image sub resource range. Okay. What chance I could do this? No. Not gonna work, unfortunately. Okay. Aspect... oh, come on. Aspect mask is going to be... VK image aspects... color bits? Yeah. Base map level is that. Level count is 1. Base array layer is 0. Layer count is 1. I don't know what that means. Gonna make it quite verbose here because I definitely don't want to fuck that up. I want to know what all this shit does. Base array. Whoops. Base array layer. And layer counts. That seems fine. The components field allows you to swizzle the color channels around. Okay. For example, you can map all the channels to the red channel for a monochrome texture. You can also map constant values of 0 and 1 to a channel. In our case, we'll stick to the defaults mapping by accepting the constructed defaults, but here's how to explicitly do it. Yeah, okay. If we can specify a default, that's great, but this is initialized to null, so I'm going to assume we want to... VK component mapping. Let's see. Nope. Is there a default struct in here? Sure. There doesn't seem to be a default. Oh, you literally just pass in identity to each of them. Sure. Okay. Oh, for God's sake. Right. VK image view what? No. VK component mapping. And then that's going to be like this. Yeah. Wordy, but sure. We'll make it explicit. The sub-resource range field describes what the image's purpose is and what part of the image should be accessed. Our images will be used as color targets without any mapping levels or multiple layers. Note, you can either list all elements of their sub-resource range, as it's done in the code snippet above, or use designated initializers just to initialize those members that differ from the default values, like this. Yeah. Cool. If you were working on a stereographic 3D application, then you would create a swap chain with multiple layers. You could then create multiple image views for each image representing the views for the left and right eyes by accessing different layers. Swizzles you cutely. I should eat dinner. Oh, I will be ending off when dinner's ready over here. But for now, I'm just gonna keep going. Okay, so swap chain with multiple layers. So we only have one, but then Do you mean, I guess stereographic, sure. You can then create multiple image views for each image, representing the views for left and right eyes by accessing different layers. Sure. Yeah, okay, so each swap chain image can have multiple layers, I presume. Image array layers 1. That's probably it, yeah. So if we were doing VR, then that could be left and right eye or whatever you want to do. The maximum number of multiple image views you should expect graphics cards to handle is 16. This configuration covers most standard use cases. VR/AR headsets typically require no more than 4 simultaneous views. However, light field displays and cave displays might require a different solution, as their view requirements can number in the thousands for simultaneous views. Wow. Those exotic requirements for rendering are beyond the scope of this tutorial, but even those use cases can be rendered to with these same structures and techniques we describe here. Next, set up the loop that iterates over all the swap chain images and add them to our structure. Alright, great. Oh, wait. It's already... Yeah, it's just create info. Sure. Uh-huh. And image view... Oh, wait. Oh, okay, gotcha. Create info dot image equals... Huh? Interesting. Adds them to the structure? I don't know if that's what that's doing. That looks very much like it's just overwriting it each time. Yeah, it's a single image. Okay. I'll do it. It's just a little confusing. Whatever. Oh, wait. Creating the image view is now a matter of using the constructor of create image view here via standard vector and place back. Oh, fucking hell. Okay, that part's gonna be weird. Swap chain image views and place back. What? Appends a new element to the end of the container. The element is constructed through that, which typically uses placement new to construct the element in place at the location provided by the container. Okay, so it's append, I guess? And I presume it's one image view per swap chain image just because of our current setup, so... This was allocated, yeah? Yes, it was. Okay. Ah, okay. Yeah. Right. Okay, we use the same create info for each one. Oops. And then the image view will be app vk swap chain image views. That's for creating a single one. And then it, like, tacks it to the end. Okay, okay. I think I'm getting it. This is never set, so we need to set it. And that's probably going to just be the same value as VK swap chain image views. Or, sorry, and swap chain images. Now we need to malloc it. Or do we? I think we do. I'm curious. I'm gonna check something because I don't recall having to do something like this. I'm gonna have a look at some old code that I had kind of ripped from elsewhere and see how I went about this. Huh. Sure. Actually, yeah, there's a couple things that were done differently here. 1 second. Let me just quickly... That's a little bit tidier. And yeah, components was actually left uninitialized there, so we will probably do the same. Sure. Ah. Okay. Yeah, I'm gonna break away a little bit here and I will do this real quick. So it does seem like this is what's going on here. Oh God, right. There we go. So swap chain image views is that, sure. Uh-huh. Yeah. And then we do indeed swap chain image views. This then becomes a malloc. Kind of no way around it because that's going to get passed around a bit. Size of VK image view multiply by that, and now we can do this. Actually, kind of doesn't matter. We'll go through this. We have our create info. We pass through all of the things we want, and image goes over here. Yeah. Okay. Amazing. The indentation, or that line length is less amazing, but we ball. Oh, shoot. Right. I should probably specify the index. That would be a good idea. Yeah. Okay, that's all fine. SL error. I don't know why it brings you to the beginning of the line when I do that. Some stupid Lua snip thing, I guess. Don't know what's going on there. Error. Yeah, just failed to create Vulkan image view. Oh, right, yeah. Because I do actually want to store the results here. Should probably then free that. I mean, it kind of won't matter as well. Because, I mean, the app's going to then have to crash anyways. We'll be a good citizen. We'll be a good citizen. Swap chain image views. Actually, VK destroy image. Yeah. Let's do this real quick. Swap chain images. Cool. Swap chain image views. Ah, right. Uh-huh. Hold on, what? Swap chain image views. Why? Oh, right. There you go. Cool. That should now be responsibly freed. Right. Fantastic. So we don't have to free it here, because if we error, then we're going to go to Vulkan destroy after that. Well, technically the whole app returns first, but yeah, If app VK swap chain image views is not null, then we'll go and go through here. That should keep it pretty safe. So we can kind of just run destroy at any time, and it's pretty much guaranteed to work. I'm gonna skip this one. If my media keys would ever work, that is. Yeah, this is fine. All right. Swap chain images is not null. And if app VK device is not null, then we destroy the device. We do the same with the surface. And we do the same with the instance. I mean, it'd be kind of hard to destroy without that, but, you know, it's safe. It's safer. Okay. So yeah, for each image that we have in the swap chain, we create a new view just for that, is basically how this ends up working. And then, yeah, we iterate through this. Yeah, create image view, that's all fine. If that fails, then we can return SL error Vulkan. And yeah, swap chain image views at this point will be a non-null value. So we can then, there isn't currently a function really to, well, we have Vulkan in this actually. To be fair, we can still do this. Let's, we'll do void quit or something, which just takes in app state app. Oops. Cool. And then we'll run quit with the app. Yeah, so if Vulkan fails, we'll responsibly tidy up. I'm just going to assume it is broken. We segfault. Lol. Alright, that's great. Where is that? That's after device selection. Swap chain should be created. Image views. I wonder where that problem is. Okay, we do get that far at least. I wonder, is it, say, right here or something? Ooh. We segfault before that. Is it VK swap chain images indexing? It is, it is. Okay. Which means we never actually mallocked that properly. Ah. Yeah. Yeah. I suppose I just assumed it would have been allocated, but that was a mistake on my part. That's fine. We do set end swap chain images, don't we? I don't believe we... Wait, no, we do. Get swap chain images. That should allocate it for us. That would be my thinking anyways. But I might be very, very wrong. That's just a handle. Yeah. That's very interesting. Okay. Let me think about this. Perhaps... Yeah, okay. Okay, I think I know what's wrong here. This is one of those cases where I don't actually know the number of images yet, so I actually do need to store that somewhere. So that's going to be... Yeah, we kind of already get that from here, so that's fine. Fail to retrieve number of swap chain images. And then once we have them, then app vk swap chain can be allocated. VK image. Oh, size of VK image multiplied by app VK and swap chain images. Okay, well that's better. We didn't segfault immediately. The swap chain must be a valid VK swap chain KHR handle. Okay. Oops. Okay, great. We do create them. Okay, we get destroy things, destroy errors, but that's fine. We'll actually figure that out in a moment. We do get all the tests, though. That's good. All of the swap chain images get created, and the game starts. Destroy image. A presentable image controlled by the implementation must be destroyed with VK destroy swap chain KHR. Ah. Gotcha. Okay. Well, I guess the swap chain is created at this point. So, app vk swap chain. Image must not have been acquired from that. Yeah, so we destroy it first. We destroy it first. And... yeah. And I don't believe swap chain was ever mallocked. Yeah, because it's a handle. That should work now. Wow, no, that made it worse. Okay, that's fine. Let's look at this. Couldn't find VK image objects. Ah, it's probably already handled then, if I had to guess. Yeah. Okay, so just destroying it via swap chain should actually be fine. Cool. I guess that contains all of the, like, the images and image views within. No, also upset. We can't destroy device for that. Oh, no, the image view has not been destroyed. So we do want to keep image view destruction. I suppose that maybe destroys the image as well. It does. And if I keep in image destruction, then it complains because it doesn't exist anymore. Okay. That is fine by me. I'm just here trying to be a good memory citizen and tidy up everything as I go. Cool. Yeah, looks good. That's fine. Perfect. Wait, does this... Probably gonna do this, yeah? Yeah, we're good. Okay, cool. We do now create the swap chain image views. Fantastic. Those are all created. An image view is sufficient to start using an image as a texture, but it's not quite ready to be used as a render target just yet. That requires one more step, known as a frame buffer. In the next chapters, we'll have to set up the graphics pipeline. Okay, this gets exciting. We have graphs, everyone. We have diagrams. There's pretty pictures on screen. With the full Vulkan pipeline. Hold on, where's the image? I gotta get it. I swear I have it here. Beware the Vulkan pipeline, everyone. We're doing it in real time. We got the vertex input assembly, the vertex shader, rasterization, fragment shader. Oh shit, I forgot to clear the depth buffer. Oh god, what the fuck is this? What does that say over there? I can't even read that. That's beautiful. You love to see it. Right. Oh my god, introduction. Graphics pipeline basics. We're on presentation. Or we're past presentation. We've got this preamble. Now it's the graphics pipeline. Over the course of the next few chapters, we'll be setting up a graphics pipeline configured to draw our first triangle. The graphics pipeline is the sequence of operators that take the vertices and textures of your meshes all the way to the pixels in the render targets. A simplified overview is displayed below. Cool. Input assembler, where we put in our actual vertices into memory. Vertex shader, which moves them around as we need. Tessellation, which I guess, yeah, more of a like in the middle thing. But it is a part of it. That is important. Geometry shader does extra shit. We're probably not going to deal with geometry shaders right now, but yes, that is a thing. Rasterization, which is fill the pixels on screen. Fragment shader, color the pixels on screen. And then color blending. We put them all together. And then it goes to the frame buffer. Delightful. The most important, I believe, is going to be input assembler and rasterization, then color blending. Everything else in here is kind of optional. You don't need a vertex shader. You could move your vertices on the CPU, but we are going to be doing that because that's much easier to work with. Tessellation, we're probably not going to be dealing with tessellation for a 2D tile-based game. Geometry shader, also quite unlikely, but we'll see. Maybe instancing or something comes in handy, but I doubt it. Rasterization is going to be very important. Fragment shader... Yeah, fragment shader will probably be used for applying textures. Tessellation is a Thermia reference. Cool. Right. The input assembler collects the raw vertex data from the buffers you specify and may also use an index buffer to repeat certain elements without having to duplicate the vertex data itself. Big fan of index buffers. Very good. The vertex shader is run for every vertex and generally applies transformations to turn vertex positions from model space to screen space. It also passes per vertex data down the pipeline. The tessellation shaders allow you to subdivide geometry based on certain rules to increase the mesh quality. This is often used to make surfaces like brick walls and staircases look less flat when they are nearby. Is that not where normal maps come in? I think that's I feel like normal mapping and stuff can be used either during the vertex portion or rasterization portion, depending on how your render pipeline is done. But yeah, sure. The geometry shader is run on every primitive, triangle, line, and point, and can discard it or output more primitives than came in. This is similar to the tessellation shader, but much more flexible. However, it is used little in today's applications because the performance is not that good on most graphics cards, except for Intel's integrated GPUs. Also, almost all geometry shader use cases can be fixed with a more modern mesh shader pipeline, which, like ray tracing, is a wholly new pipeline solution, so it exists outside the standard graphics pipeline setup. We'll discuss that pipeline in a future tutorial section. Mesh shader. I'm thinking that's instancing. Yeah. I think that's what that refers to. The rasterization stage breaks the primitives into fragments. These are the pixel elements that they fill on the frame buffer. Any fragments that fall outside the screen are discarded, and the attributes outputted by the vertex shader are interpolated across the fragments as shown in the figure. Usually, the fragments that are behind other primitive fragments are also discarded here because of depth testing. The fragment shader is invoked for every fragment that survives and determines which frame buffer or frame buffers the fragments are written to, and with which color and depth values. It can do this using the interpolated data from the vertex shader, which can include things like texture coordinates and normals for lighting. The color blending stage applies operations to mix different fragments that map to the same pixel in the frame buffer. Fragments can simply overwrite each other, add up, or be mixed based upon transparency. Yeah. Okay. Cool. Stages with the green color are known as fixed function stages. These stages allow you to tweak their operations with the green color? Oh, fixed function stages allow you to tweak their operations using parameters, but the way they work is predefined. Yes, input assembler works a certain way, rasterization works a certain way, color blending works a certain way, but they can be configured. These ones are very kind of freeform, is as I understand it from reading that. Stages with an orange color, on the other hand, are programmable, which means that you can upload your own code to the graphics card to apply exactly the operations you want. Yes, shaders. This allows you to use fragment shaders, for example, to implement anything from texturing and lighting to ray tracers. These programs run on many GPU cores simultaneously to process many objects, like vertices and fragments in parallel. If you've used older APIs like OpenGL and Direct3D before, then you'll be used to being able to change any pipeline settings at will with calls like glblendfunc and omsetBlendState. The graphics pipeline Vulkan is almost completely immutable, so you must recreate the pipeline from scratch if you want to change shaders, bind different frame buffers, or change the blend function. The disadvantage is that you have to create a number of pipelines that represent all of the different combinations of states you want to use in your rendering operations. However, because the operations you'll be doing in the pipeline are known in advance, the driver can optimize for it much better. Yeah, in the talk that kind of led to me going down this rabbit hole, I'll quickly drink some water real quick. 1 second. It's time to drink water, everyone. If you have water with you, you should drink it. If you don't have water, you should go get some, because water's good for you. Yeah. In the talk that I was watching that led to me doing this in the first place, they did mention that the render pipeline is immutable, and there can be a performance cost incurred by swapping between your different render pipelines, and I presume then stitching them together or something, whatever it is you're trying to do. Another option that they seem to support, be more in favor of for like an indie dev who doesn't want to build all that extra infrastructure, is essentially making a mono shader where you've just got like a whole bunch of like if-else statements that will determine what kind of material you're using. I would probably prefer the multiple pipeline strat, but we'll see. And also the fact that, it's all known in advance, then, because the render pipeline is then immutable, yeah, the driver can optimize it. So perhaps whatever penalty might be incurred from swapping between render pipelines is mostly compensated for by the whole thing being precompiled and then known and optimized and everything. Some of the programmable stages are optional based on what you intend to do. For example, the tessellation and geometry stages can be disabled if you're just drawing simple geometry. If you are only interested in depth values, then you could disable the fragment shader stage, which is useful for shadow map generation. In the next chapter, we'll create the 2 programmable stages required to put a triangle onto the screen, the vertex shader and fragment shader. The fixed function configuration, like blending mode, viewport, rasterization, will be set up in the chapter after that. The final part of setting up the graphics pipeline in Vulkan involves a specification of input and output frame buffers. Cool. Yeah. Right. Create a create graphics pipeline function that is called right after create image views in init Vulkan. We'll work on this function throughout the following chapters. We are nearly at the end of the page. Oh, yeah, we're at the end of the page. Cool. Set up dynamic rendering. We technically haven't done that yet. Perhaps that's done as part of the graphics pipeline. I'll keep it in mind. We'll do create graphics pipeline. Cool. And we'll take in app state app. And we will, by default, return SL error OK. All right. In the next chapter, we'll talk about shader modules required to actually put something on screen. Wonderful. This is going to be long. We might be able to clear this before the end of the stream, but we'll see. We'll see. We're actually going to, write down the vertex positions. That's exciting. If I recall correctly, we're specifying the coordinates, I think, within the shader itself for the sake of brevity. Yeah, interesting choice, but it'll be elaborated on later how to actually make a vertex buffer and whatever. It will be good. Unlike earlier APIs, shader code in Vulkan has to be specified in a bytecode format as opposed to human-readable syntax like GLSL, slang, and HLSL. This bytecode format is called SPIR-V. And is it SPIR-V or SPIR-5? SPIR, the standard IR for parallel computing graphics. I'm going to say SPIR-5. No, we're going to say SPIR-V. It's faster. Hopefully you all know what I mean, though. What a cool diagram. Yeah. All these different languages, they just go into SPIR-V and then they go out to the APIs. This is WebAssembly for graphics cards, I believe. We agree on that? Sperm is so funny. Yeah, SPIR-V is just WebAssembly for graphics cards, I believe. Wait, SPIR-V Cross can work with metal. Interesting. Well, that's cool. Nice. Bytecode format is called SPIR-V and is designed to be used with Vulkan, a Chronos API. It is a format that can be used to write graphics and computer shaders, but we will focus on shaders used in Vulkan's graphics pipelines in this tutorial. The advantage of using a bytecode format is that the compilers written by GPU vendors to turn shader code into native code are significantly less complex. The past has shown that with human-readable syntax like GLSL, some GPU vendors were rather flexible with their implementation of the standard. If you happen to write non-trivial shaders with a GPU from one of these vendors, then you'd risk another vendor's driver rejecting your code due to syntax errors, or worse, your shader running differently because of compiler bugs. With a straightforward bytecode format like SPIR-V, that will hopefully be avoided. However, that does not mean that we need to write this bytecode by hand. Kronos has released their own vendor-independent compiler that compiles slang to SPIR-V, and I do have it. I believe it is... Is it SPIR-V... what is it called? GLSLC. I think. GLSLC. Help? Yes, we do have it installed. And this will be compiling our shaders for us. Lovely. Because we will be writing in GLSL. It's just easier. I don't really feel like learning HLSL right now. Well, we quickly have a look at it. Yeah, let's be real. GLSL is more popular anyways. We're just going to use it. Doesn't OpenGL also have SPIR-V support, or am I misremembering? It's... I don't know. GL specialized shader. Oh yeah. Wait. No? Oh, okay. Specializing a SPIR-V shader is analogous to compiling a GLSL shader. Yeah, so I think you could just provide a SPIR-V shader and GL will take it. You just use a different function for it. Cool. That's nice. I also really like the fact that if you were migrating away from OpenGL, you could keep your shaders exactly as they were. That's very nice. Right. Yeah. Cool. This compiler is designed to verify that your shader code is fully standards compliant and produces one SPIR-V binary that you can ship with your program. You can also include this compiler as a library to produce SPIR-V at runtime, but we won't be doing that in this tutorial until we get into reflections sometime in a future chapter. Although we can use this compiler directly via slang-C, we'll be using slang-C in our CMA build process instead. Yeah, so they're using slang as their language. We will not, but I should be able to translate to GLSL reasonably well. A lot of programming languages, like when you've gotten to understand one, you kind of understand them all in a way, unless they have like really weird esoteric syntax. You can usually translate them pretty well, and I know enough GLSL to get by. It's very C-like, which works for me. Just checked, OpenGL added SPIR-V in 4.6, so like not available to use on Mac, but it is there. Yeah, which is why we're using Vulkan, because then it will be supported. Might as well read this even if we're not using it. Slang is a shading language with a C-style syntax. Programs written in it have a main entry point which is invoked for every object. Like HLSL, slang uses parameters and return values for input and output, with annotations to help describe what those variables relate to. The language includes many features to aid in graphics programming, like built-in vector and matrix primitives. Functions for operations like cross products, matrix vector products, auto-differentiation for AI, and reflections around a vector are included. The vector type is called float, with a number indicating the number of elements. For example, a 3D position will be stored in a float 3. Cool. It is possible to access single components through members like .x, called the swizzle operator, but it's also possible to create a new vector from multiple components at the same time. For example, the expression float3, 123.xy, would result in float2. The constructors of vectors can also take combinations of vector objects and scalar values. For example, a float3 can be constructed with float3, float2, 1 and 2, and 3. As the previous chapter mentioned, we need to write a vertex shader and a fragment shader to get a triangle on the screen. The next two sections will cover the slang code. For those, I guess. And after that, I'll show you how to produce one SPIR-V binaries and load it into the program. Cool. The vertex shader. The vertex shader processes each incoming vertex. It takes its attributes like world position, color, normal, and texture coordinates as input. The output is the final position in clip coordinates and the attributes that need to be passed on to the fragment shader, like color and texture coordinates. These values will then be interpolated over the fragments by the rasterizer to produce a smooth gradient. A clip coordinate is a 4-dimensional vector from the vertex shader that is subsequently turned into a normalized device coordinate by dividing the whole vector by its last component. Okay. These normalized device coordinates are homogeneous coordinates that map the frame buffer to a -1 to 1 by -1 to 1 coordinate system that looks like the following. Yeah, okay. Gotcha. Clip coordinates. Gotcha. That makes more sense. Yeah. I'm familiar with the fact that this mapping happens. I didn't know that we were calling them clip coordinates. That's cool. Oh no, clip coordinates is the 4-dimensional vector. Normalized device coordinate is the -1 to 1. That makes sense. You should already be familiar with these if you've dabbled in computer graphics before. If you've used OpenGL before, then you'll notice that the sign of the y-coordinates is now flipped. The z-coordinate now uses the same range as it does in Direct3D from 0 to 1. For our first triangle, we won't be applying any transformations. We'll just specify the positions of the 3 vertices directly as normalized device coordinates to create the following shape. Yep. That would be... let me think here. -0.5, 0, and then... Wait, no? It would be 0 minus 0.5 here, like 0 on the x because it's in the middle, and minus 0.5 on the y because it's kind of like halfway up the middle here. And this would be minus 0.5 plus 0.5, and then 0.5, 0.5, I believe. Nailed it. Well, kind of. They've drawn us in a different order. I went backwards. Yeah, but vertex 0 would be this, vertex 1 is that, and vertex 2 is this. Makes sense. We can directly output normalized device coordinates by outputting them as clip coordinates from the vertex shader with the last component set to 1. That way, the division to transform clip coordinates to normalized device coordinates will not change anything. Normally, these coordinates would be stored in a vertex buffer, but creating a vertex buffer in Vulkan and filling it with data is not trivial. Therefore, I've decided to postpone that until after we've had the satisfaction of seeing a triangle pop up on the screen. That is fair. We do want to get triangle %. We're going to do something a little unorthodox in the meanwhile. Include the coordinates directly inside the vertex shader. Yes. Cool. Yeah, and that is going to be interesting compared to the norm. Let me pull up my code here. My old code. Vertex shader. Shoot. We might need to use slang, actually. Well... No, we might be okay. I'm gonna need to poke at... Let me quickly check something. I need to sanity check real quick. Vertex input, info, yeah. So you can configure the inputs and outputs of your shaders. What they've done is make it so the vertex shader basically has no inputs and only outputs. And yeah, I think that's something that I can still do in GLSL. Because I do want to stick to GLSL if I can. What the fuck? Yeah, that's... I don't even know what that's doing there. I thought I found it weird that those were there. Yeah, whatever. We'll ignore that. Don't worry about it. SRC... shaders. And I'll have to actually specify another mason.build here so that these build into the directory I want. Thankfully, I can copy a lot of this code. GSLC, find program, GLSLC. If you have the Vulkan SDK, you should have GLSLC as part of it. Custom targets, vertex, let's say that. We're just going to call these like default.verts for now. Output, vert, default, SPV. Just do vertex.spv. Install true. Install directory is shaders. This is like when the app's actually getting installed. But because we have these in a subdirectory, the idea is from our program, we're going to go like from the program's working directory, we check shaders / the shader name. But of course, we're dumping everything into a build directory. So if we mimic this, where like a Mason build has like a separate directory here, then it should dump everything into a shader directory in the build directory. Hopefully that makes sense. Please let me know if it doesn't, because I mean you'll see. We need to specify the shader stage. We need to specify the outputs. I am just straight up copying from what I had before because, you know, these commands already worked. I don't need to do them a second time. Fragments, fragments, shader stage, frag. Cool. And now I think in our base mason.build, I just need to do subdirectory shaders. Lovely. Cool. What even is slang? Okay, looking at it now. This looks like C++ and C# combined to become a fucked up GLSL. Yeah, I'm not a fan. I'm not a fan. We are going to use GLSL if we can help it, because I don't like their syntax. I don't like Spurvy's, or sorry, I don't like slang syntax. Let's go back into my shaders, because I can copy most of this still. Yeah, most of this is fine. We no longer have in position or in color. We are just going to comment those out for now. Out, frag color, yeah. Probably going to end up being this, though. Positions, float 2, yeah. We'll do position. GL position is... Uh-huh. Okay. Just thinking about this. I think, yeah, no, that's probably fine actually. We could probably just specify a vec3. I don't know if I have this right at all. We're gonna find out. Cool. Oh, it needs to be vec2, my bad. We'll say that's 0. Effect 2, 0, 0.0, 0.5. In fact, I'm going to put the 0.0 in there because that's kind of how I want this to be styled later. Yeah, that should be good for positions. I have no idea if that's gonna actually work. Let's say, hold on, GLSL validator. Is this a thing? Type checker? Sure, bud. Static is a reserved word. Okay, what if I remove static? What the hell? There's no symbol called layout in the current scope. Okay, that's confusing. Okay, that seems like a really bad GLSL checker. That's really weird. Tell you what I'll do. Let's just see, does it compile? Because this should now include... Ah. Fragments. Oh, right. I never put in a fragment shader. My bad. My bad, slime. Thankfully, this is stupid easy. In fact, we're gonna ignore this for now. And we're just gonna do... Well, do we... Yeah. We'll try and get a pink triangle in here, maybe. In fact, hold on a second. I'm gonna try something funny. Let's see, what am I looking for here? Ah, here we are. Shit, wait. Okay, 0.6. This'll make sense later, I swear. 170, 255. Sure. We're just gonna do that, actually. That should be enough. 0.733. Not 1,000,000%. Oh, wait, I didn't even paste the right fucking thing in there. My bad. Thought that looked weird. Okay, we're gonna copy that. Nope. 0.718. That's fine. 253, 255, 992, and 73. That is 0.286. Cool. Looked at the slang source code. Immediate warning about a block to distribute to it. Of course it's Claude. Of course it's Claude. Right. Alright, let's see if it compiles. Hated the fact that I used static in there. Constructor, too many arguments. Oh, whoops. That would do it. Vert 16. It doesn't like constructing non-array constituent. Oh. I still need like the vertex ID. I suppose maybe I can do this actually. Hold on. We'll do a vertex index. Maybe you? Ooh! Okay! So now, if we're going to build, debug, shaders, we have vertex. And we have fragments. Wonderful. Beautiful. Shouldn't have to touch those shaders for a while. Okay. Fantastic. That should give us equivalent to what they're doing here. That's the hope anyways. I really, really hope I'm right. Okay. The vert main function is invoked for every vertex. The built-in SV vertex ID annotated variable in the parameters. Yeah, we can ignore this slang specifics. We are going to ignore slang here. In this tutorial, we're going to demonstrate best practices by keeping the shaders to a single file. If you know GLSL, there's GLSL versions of the shaders in the attachments folder, which are direct translations. Hooray! I might actually want to look at those. Where are the attachments? GLSL, vertex, and fragments. We will have a look at that. I was remarkably close, actually. Oh, they also specified the colors. Yeah, we're going to specify the colors. Interesting. They did use different syntax there. I imagine that is important though, so I am gonna keep what they did. And they do keep output frag color. And yeah, I suppose you didn't need to specify out position because that's what GL position is for. So that's fine. Frag color, colors. Oh, wait. Oh, we already get this for free. GL vertex index. Lovely. That's fantastic. Let's see here. Ah, and yes, the colors are, of course, quite a bit different here. We'll do this. Nice and easy. Whoops, not 2. Yeah. That all looks fine. Nice and clean. What's your fragment shader look like? Similar? Still takes in frag color, because we do actually then pass that around. And I mean, like, yeah. I guess we'll do that. I'll experiment with that later, I guess. And let's compile. Ooh, big bad, big bad. Syntax error in default vert line 12. Is it the... didn't expect the extra comma, I bet. Ooh, it hated that. Bingo! We're so back. Okay. Back to business. Did this say version 450, by the way? Yes, we're using 450, so we're good. Fantastic. Cool. Fragment shader. The triangle formed by the positions from the vertex shader fills an area on the screen with fragments. The fragment shader is invoked on these fragments to produce a color and depth for the frame buffer, or frame buffers. A simple fragment shader that outputs the color red for the entire triangle looks like this. We're going to ignore that. Per vertex colors, making the entire triangle red is not very interesting. Wouldn't something like the following look a lot nicer? Pretty. We have to make a couple of changes in both shaders to achieve this. Yeah, okay, so it's all this shit that they... Yeah, we've already done this. Compiling the shaders. Yep, done, 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 done. Loading a shader. Now we get somewhere interesting. We are going to need something to load our shaders, which actually won't be too hard. SDL has a read file. That's actually fine. So we won't bother with writing our own abstraction around it. We can use SDL. Okay. Cool. Okay, so in Create Graphics Pipeline, that's where we then can load our shaders. SDL load file. And we're going to do const char pointer vertex code, I guess. Let me close this side panel because it's in the way. SDL load file, and we are going to do... these shouldn't be hard-coded, but... vertex code file path. Vertex shader path. Vertex, and this one will be fragments. Cool. So we can now specify vertex shader path, and the data size we don't know. We're gonna get that. Vertex code size. Beautiful. Great. So we'll do that for both our shaders. Cool. And from that, they're both done. And we don't even have to close them, I don't think. Yeah, it just loads the data. The data should be freed with free. Okay, we do at least have to free the data. That makes sense. Cool. Why are you... Ugh, seriously. Oh, it returns a void pointer. I suppose that makes sense. Awesome. Cool. Creating shader modules. Okay. Shader module, create shader module with the code. Oh, right. We have a function. Yeah, makes sense. And we take in the code, yeah, app state, app, and they have a const char pointer for code, so we will do it like that. And by default, we return SL error OK. The function will take a... Oh, wait, because that does output a shader module then as well. So let's do VK shader module. Yeah, I think we'll do it this way. The function will take a buffer with the bytecode as parameter and create a VK shader module from it. Creating a shader module is straightforward. We only need to specify a pointer to the buffer with the bytecode and the length of it. This information is specified in a VK shader module create info structure. Yeah, we'll do. I think we'll just look at it. Shader module create info. We'll do that. Initialize it to 0. We're going to specify the S type. Like that. And what have we got? Code size is going to be, I should definitely specify the length. Cool. Create info p code. Code. Why are you unhappy? Const UN32T pointer. What? Oh, really? The one catch that the size of the bytecode is specified in bytes, but the bytecode pointer is a UN32T pointer rather than a char pointer. Therefore, we'll need to cast the pointer with reinterpret cast as shown below. When you perform a cast like this, you also need to ensure that the data satisfies the alignment requirements of UN32T. Lucky for us, the data is stored in a standard vector. The default allocator already ensures it. Oh. Mine doesn't, but I don't think I had a problem with this before, so we are going to extremely lazily cast a UN32T pointer. I know we shouldn't, but I'm doing it anyway. Because byte alignment and whatever, blah. Module crate flags. What do we got? Device only bits. Do we even need to specify that? Yeah, not really. Okay. And then the module, oh wait, VK create, what? Shader module. There we go. App VK device. Create info would be this. The allocator is null. And the shader module is module. Returns VK results. So Vulkan error. And we will SL error. Lua snip shitting itself again. That's fine. Failed to create shader module, and we will just say string VK results, crying again, results. Cool. That was easy. And do I need to deallocate anything after that? No, not really. It's a handle. Yeah, it's fine. We're all good. Yeah. Okay. Yeah. Sure. I mean, you've gone and simplified it into like one little line here, but I'm fine doing it this way. Let's do Vertex module is a VK shader module. And we are going to SL Vulkan. It's a lot. Wow. Create shader module, which will take in... That takes in device, doesn't it? Yeah, it does. We're gonna do VK device because that's a slightly better way of doing it. We really don't need access to all of app states. So app VK device. The code is going to be vertex code. The code size is vertex code size. And the module is going to be vertex module. Lovely. And we do get a error off of that, so we will accommodate for this. That will be SL error results equals that. And if result is not SL error okay, we will return the results and we'll like early bail out of it. Actually, we won't do that because we do. The shader module should already be created actually. Shader modules are just a thin wrapper around the shader bytecode that we've previously loaded from a file and the functions defined in it. The compilation and linking of this purview bytecode to machine code for execution with GPU doesn't happen until the graphics pipeline is created. That means we're allowed to destroy the shader modules again as soon as the pipeline creation is finished, which is why we'll make them local variables. Okay, yeah. So we can't just free vertex code immediately after, like, whatever the result is. We will still need to, like, early bail here, but, you know, we'll keep it in mind. Cool. Good. Cool and good, even. Keeping my lines of code under 80 where I can. I can get them kind of close, but it's tricky. Cool. Okay. Very nice. Yeah. Shader stage creation. To actually use the shaders, we'll need to assign them to a specific pipeline stage through VK pipeline shader stage create info. Of course we will. I need shader stage create info. Yeah. It's not shader module create info. That'd be shader. Hello? Stage? Pipeline shader stage create info. Okay, and you take a couple things. All right. So the stage is going to be VK vertex. Okay. Stage vertex. There we are. And the module is going to be vert module. Vertex module. And the P name is vert main. I think I know what they're talking about. I think I can just call it vertex. I'm sure it's fine. The first two parameters are the flags and the stage we're operating in. The next two parameters specify the shader module containing the code and the function to invoke, known as the entry point. That means it's possible to combine multiple fragment shaders into a single shader module and use different entry points to differentiate between their behaviors. I hope just vertex is fine. I'll be right back. I'm going to the bathroom real quick. Take a moment to drink some water, take a break of your own. I'll be right back. right, we're back. Let's get back to it. Knock down the volume like one tiny notch again. That's okay. Good. Right, vertex stage. We kind of have that. I hope p-name is okay. I'm gonna quickly double check again, you know, we're code that worked before. I just didn't understand it very well, but let's see. P-name. I used main, apparently. That makes sense. Are they called main in here? Oh, for God's sake, they are called main. Yeah, that makes sense. Sure. And... Ah. Huh. I just noticed a cool thing that I did, actually, during... like, in that old code. I can make an array of them. And then I can just do this. And I can say this is a fragment shader, the fragment module, and it stays as main. Cool, that's nice. Very clean. Modifying the structure to suit our fragment shader is easy. Indeed. I did it. Pretty easy. Finished with defining an array that contains these two structs. Hey, literally the thing I did. And we're all good. We'll look at the fix function stages now. The older graphics APIs provided the default state for most of the stages of the graphics pipeline. In Vulkan, you have to be explicit about most pipeline states, as it'll be baked into an immutable pipeline state object. In this chapter, we'll fill in all the structures to configure these fixed function operations. Dynamic state. While most of the pipeline state needs to be baked into the pipeline state, a limited amount of the state can actually be changed without recreating the pipeline at draw time. Examples are the size of the viewport, thank God, line width, and blend constants. If you want to use dynamic state and keep these properties out, then you'll have to fill in a VK pipeline dynamic state create info structure like this. Huh. This will cause the reconfiguration of these values to be ignored, and you'll be able and required to specify the data at drawing time. This results in a more flexible setup and is widespread for things like viewport and scissor state, which would result in a more complex setup when being baked into the pipeline state. Interesting. Okay. Well, let's say we did. That would be VK dynamic states 2. VK dynamic state E viewport. There. And scissor. Cool. Those are definitely things I could see myself wanting to play around with. VK pipeline. Ugh. If I don't get the casing right for long enough, it gets really confused. What? There we go. And dynamic state info. Dynamic state count is size of dynamic states divided by size of VK dynamic states. Cool. Dynamic state info, dynamic states is dynamic states. Fine. Okay. You'll be able and required to specify the data at drawing time. Okay, yeah, perfect. That's actually fine. Oh yeah, it would be more complex if baked into pipeline state. Yeah, so it's very good that we did this. I was kind of unsure on what it was advising here, but yeah, no, dynamic state definitely good. Yeah, the fact that we have to specify at a drawing time. Oh no, I have to tell you the resolution when you're drawing. Yeah, okay. The VK pipeline vertex input state create info. I'm going to turn this up a little. Yeah. Describes the format of the vertex data passed to the vertex shader. Cool. Yeah. Oops. Vertex input state create info. You know the deal. S type VK structure. Vertex input state info. Oh. Not at all what I intended to do. Cool. Vertex input info. These will be interesting to get to in a moment. We will get to them. Describes the form of the vertex data that will be passed into the vertex shader. It describes this in roughly two ways. Bindings, the spacing between data and whether the data is per vertex or per instance, see instancing, and attribute descriptions, the type of the attributes passed to the vertex shader, which binding to load them from, and at which offset. Because we're hard coding the vertex data directly in the vertex shader, we'll fill in the structure to specify that there is no vertex data to load for now. We'll get back to in the vertex buffer chapter. Yes, that makes sense. The p-vertex bind descriptions and p-vertex attribute descriptions members point to an array of structs that describe the aforementioned details for loading vertex data. Add this structure to the create graphics pipeline function right after the shader stages array. Yeah, I guess well, if the count's always left to 0, we're not really doing anything with flags, I reckon. Front bit. Oh, that's call mode flags. Wait, is that what it's asking for? Input state create flags. Is this used ever? Vertex input state creates flags. Must be a stub. Yeah, they don't really have any flags for it, necessarily. Unless call mode flags like fit into this somehow, but I'm pretty sure they don't. I think that's specified elsewhere. Yeah, so we can already just have that. And because the underlying like counts for these are going to be 0 because we 0 initialized, then we, just won't load any in per vertex. I see what you did there. I see what you did there. Add this structure to the create graphics function right after the shader stages array. Done. Already done. Yeah, all good. Input assembly. The VK pipeline input assembly state create info struct describes two things: what kind of geometry will be drawn for the vertices, and if primitive restart should be enabled. The former is specified in the topology member in kind of values like points list, points from vertices, line list. Oh yeah, is it points? Is it lines? Is it triangles? What strip? The end vertex of every line is used as the start vertex for the next line. Sure. Yeah. We do need to specify this. Input assembly state create info. And we're just going to copy this because I don't feel like doing that all over again. Yeah, all good. Oops. There we go. Vertex assembly info. Topology. We VK primitive. Triangle list. Triangle from every 3 vertices without reuse. Yeah. Normally, the vertices are loaded from the vertex buffer by index in sequential order. But with an element buffer, you can specify the indices to use yourself. This allows you to promote operations like reusing vertices. If you set the primitive restart enable member to VK true, then it's possible to break up lines and triangles in the strip topology modes by using a special index of that. We intend to draw triangles throughout this tutorial, so we'll stick to the following data for the structure. Topology is triangleist. Yep. Go figure. A viewport basically describes the region of the frame buffer that the output will be rendered to. This will almost always be 0, 0 to width height, and in this tutorial that will also be the case. Lovely. VK viewport, and viewport, actually, wait, I forgot to zero initialize it. App VK extents width, I guess? Yeah, swap chain extents figures. Viewport X equals 0. Viewport Y equals 0. Anything else we're specifying? Min depth 0.0f and max depth will be 1. Remember the size of the swap chain and its images. Actually, let me just double check. Min depth, max depth. Yeah, I got that right. Remember that the size of the swap chain and its images may differ from the width and height of the window. Okay. The swap chain images will be used as frame buffers later on, so we should stick to their size. Okay, so that'll be done anyway, so that's fine. Cool. The min depth and max depth values specify the range of depth values to use for the frame buffer. These values must be within the 0 to 1 floating point range, but min depth may be higher than max depth. What? If you aren't doing anything special, then you should stick to the standard. Yeah, what? The min depth can be higher than the max depth? Sure. While viewports define the transformation from the image to the frame buffer, scissor rectangles define in which regions pixels will actually be stored. Okay. The rasterizer will discard any pixels outside the scissored rectangles. They function like a filter rather than a transformation. The difference is illustrated below. Yeah, so it's like viewport first, and then scissor triangle is like the final crop, but no more than what the viewport currently holds. Yeah, that makes sense. Note that the left scissored rectangle is just one of many possibilities that will result in that image, as long as it's larger than the viewport. Yeah. Gotcha. Oh, in this case, the viewport's been, like, moved by the looks. Yeah, it's been shifted around. So if you wanted to draw to the entire frame buffer, we would specify a scissor rectangle that covers it entirely. Seems pretty easy. Yeah. Cool. Viewports and scissor rectangles can either be specified as a static part of the pipeline or as a dynamic state set in the command buffer. Yes. While the former is more in line with the other states, it's often convenient to make viewport and scissor states dynamic as it gives you a lot more flexibility. This is widespread, and all implementations can handle this dynamic state without a performance penalty. Sweet! When opting for dynamic viewports and scissor rectangles, you need to enable the respective dynamic states for the pipeline. Yeah. Did the music just stop? Uh-oh. That's probably not good. I think I've run out of, my internet's died. I haven't run out. Yep, that's the router dead. Okay. Okay, router's responsive, we just don't have broadband. That's good. That's so good. Oh, never mind. I don't think the router is responsive. Yep. Nope. It's dead. That's cool. Guess we'll probably notify people the stream is dead. Gonna pause the recording for the time being until I've got that fixed. Are we back? I don't know. Are we back? Yep. No, that was me. My router just died. Let's try that again. Music back? Jump scare. Yeah, fucking real. I don't know what just happened there. I think my router rebooted. It does this sometimes. We are so back though. Don't even worry about it. Okay. Well, with that awkward moment out the way, let's get back to the Vulkan. No idea what that was. Cool. Okay, let's see here. What was I doing? I got so distracted. Dynamic states, yes. We already specified these, yeah. Pipeline dynamic state create info, already done. I guess you wanted me to do that after. I'm just gonna keep to that. I don't feel the need to divert that much. And then you only need to specify their count at pipeline creation time. Cool, okay. Ah, okay, gotcha. Okay. VK pipeline viewport state create info. Viewport info. Ooh, I don't specify this type in here, do I? That's all fine. VK pipeline viewport state create info will be this. Lovely. Viewport info dot. What are the things here? Flags, viewport count, viewport scissor count, scissors. Yeah. Okay. Really? Huh. Yeah, okay, sure. Viewport info, viewport count will be 1, and then the other count, scissor counts, will be 1. Is that what I did before as well? Viewport state create info. Oh no, there's hard-coded viewports in that old pipeline. Okay, this is an improvement. Oh, did the chat freeze as well? Hold on. It did. Let me fix that. Cool, we're so back. Awesome. All right. The actual viewports and scissor rectangles will then later be set up at drawing time. Okay, so we can just leave them as empty. That's fine. With dynamic state, it's even possible to specify different viewports and/or scissor rectangles within a single command buffer. Okay, interesting. Without dynamic states, the viewport and scissor rectangle need to be set in the pipeline using VK pipeline viewport state create info struct. Yeah, this makes the viewport and scissor rectangle for this pipeline immutable. Any changes required to these values would require a new pipeline to be created with the new values. Pain in the ass. Okay, yeah, so this is the ultimate struct that we end up making. That's fine. I will maybe keep that as well. Cool. Independent of how you use them, it's possible to use multiple viewports and scissor rectangles on some graphics cards, so the structure members reference an array of them. Using multiple requires enabling a GPU feature. Oh, okay. We're probably fine. The rasterizer takes the geometry shaped by the vertices from the vertex shader and turns it into fragments to be colored by the fragment shader. It also performs depth testing, face culling, and the scissor test. And it can be configured to output fragments that fill entire polygons or just the edges, wireframe rendering. All this is configured using the VK pipeline rasterization state create info structure. Yes. Good heavens. Okay, there's a lot here. Rasterization state create info. Rasterizer. Definitely going to use specify S type for this. Pipeline rasterization state create info. Bingo. Rasterizer, there's a lot of shit here, so let's just go through them one by one. VK false for depth bias clamp. We'll do this actually here. If depth clamp enable is set to VK true, then fragments that are beyond the near and far planes are clamped to them as opposed to discarding them. This is useful in some special cases like shadow maps. Using this requires enabling a GPU feature. We're gonna leave that. Oh, wait. Depth clamp enable. That's what that's supposed to be. If rasterizer discard enable is set to true, the geometry never passes through the rasterizer stage. This basically disables any output to the frame buffer. That's... yeah. That seems like a thing I might want to be false. I do actually want my triangle on screen. Polygon mode. I've seen this before, yeah. Polygon mode, I want it to be fill. Because I'm filling my triangle, not outlining it. Line width. That is straightforward. It describes the thickness of lines in terms of number of fragments. The maximum line width that is supported depends on the hardware, and any line thicker than 1 requires you to enable the wide lines GPU feature. I remember experimenting with that before and it didn't work, and it was probably because I was missing the feature. Interesting. But yeah, we're not really drawing lines anyway, so it's fine. Cull mode determines the type of face culling to use. Cull mode, we want back bits. You can disable culling, cull the front faces, cull the back faces, or both. The front face variable specifies the vertex order for the face to be considered front-facing and can be counterclockwise or counterclockwise. I think counter is the way that this is usually done. Front face counterclockwise. I will check the shader here. So point 1 is up there. Oh, it's clockwise. Never mind. That would have been awkward. Okay, we're doing clockwise. All fine. All good. The rasterizer can alter the depth values by adding a constant value or biasing them based on the fragment slope. This is sometimes used for shadow mapping, but we won't be using it. Just set depth bias enable to false. All good. Multi-sampling. The VK pipeline multi-sample trace info struct configures multi-sampling, which is one of the ways to perform anti-aliasing. It works by combining the fragment shader results of multiple polygons that rasterize to the same pixel. This mainly occurs along edges, which is also where the most noticeable aliasing artifacts occur. Because it doesn't need to run the fragment shader multiple times if only one polygon maps to a pixel, it is significantly less expensive than simply rendering to a higher resolution and then downscaling. Enabling it requires enabling a GPU feature. Huh. Yeah, they want to revisit another chapter. I want that. And I am actually kind of willing to put in the work to figure that out. Enable a GPU feature, I'm sure I can figure which one that is out. Multi-sample state create info. And what are we looking at? Ooh, okay. Never mind, I don't really understand this structure. Yeah, oh, fuck it, whatever. We'll comment it for now, but I'll leave that in there because I don't want to write that again. If you're using a depth and or stencil buffer, then you also need to configure the depth and stencil test using VK pipeline depth stencil create in a state create info. We don't have one right now, so you can simply pass a null pointer instead of a pointer to such a struct. We'll get back to it in the depth buffering chapter. Yeah, definitely not right now, but I will keep it here. I'll keep it commented or something. Yep, and there we go. Comment those out. Color blending. After a fragment shader has returned a color, it needs to be combined with the color that is already in the frame buffer. This transformation is known as color blending, and there are two ways to do it. Mix the old and new value to produce a final color, or combine the old and new value using a bitwise operation. There are two types of structs to configure color blending. The first struct, VK pipeline color blend attachment state, contains the configuration per attached frame buffer, and the second struct, VK pipeline color blend state create info, contains the global color blending settings. In our case, we only have one frame buffer. Cool. Cool. So that would be color blend attachment S. Ooh, no S type? Huh. I really expected an S type. Okay, we just have it disabled. That's fine. RBit. Cool. Oh, RGBNA. Yeah, that's fine. Let's throw those in real quick. Good. This per frame buffer struct allows you to configure the first way of color blending. The operations that will be performed are best demonstrated using the following pseudocode. Okay. If blend enable, then RGB becomes that through some blend operation. Okay. I have written a lot of code tonight, so that's kind of missing me right now. But yes, it's whether or not we want to actually enable color blending. Sure. That's fine. And then there's some, was it color blend op, was it? Yeah, and that's a VK blend op, which is... Oh. Oh. Oh, so that's how we do like screen or multiply. Okay, that's really cool. I like that a lot. Cool. Can we do multiple of these? Yeah, it's per frame buffer. Yeah, so if we wanted a buffer that was just additive stuff for like, I don't know, bloom or something, then we would write one that was just for bloom and it would have like screen and whatever. And we can even specify which colors to mask on that. Super cool. Super cool. We have it set to false anyways, but it's cool that we have it. If blend enable is set to false, then the new color from the fragment shader is passed through unmodified. Otherwise, the two mixing operations are performed to compute a new color. The resulting color is ANDed with the color right mask to determine which channels are actually passed through. The most common way to use color blending is to implement alpha blending, where he wants the new color to be blended with the old color based on its opacity. The final color should then be computed as follows. Final color RGB is new alpha by new color plus... Yeah, I'll take your word for it. This can be achieved with the following parameters. Yes, we aren't doing that right now though, as I understand it. Okay. Interesting, interesting. Do we want to use this? Sure, I guess. We can. Oh, they specified false at first. I think this is just an example. Yeah. Basic alpha blending stuff. Okay, that seems fine. You can find all the possible operations in the VK blend factor and VK blend op enumerations in the specification. The second structure references the array of structures for all the frame buffers and allows you to set blend constants that you can use as blend factors in the aforementioned calculations. Pipeline color blend state create info, color blending. Yeah. If you want to use the second method of blending, a bitwise combination, then you should set logic op enabled to VK true. The bitwise operation can then be specified in the logic op field. Note that this will automatically disable the first method, as if you had set blend enable to VK false for every attached frame buffer. The color right mask will also be used in this mode to determine which channels in the frame buffer will actually be affected. It is also possible to disable both modes, as we've done here, in which case the fragment colors will be written to the frame buffer unmodified. Sure. Interesting. How far down at this page are we? We're nearly at the end. What page is this again? Fixed functions. Yes, yes. We're getting very, very close. Very close to triangle percent. I don't know if we'll get it by the end of this stream. Kind of depends. I am actually kind of tired, but we'll hopefully get there. Yeah, if blend enable sets false, new color from fragment shader pass through unmodified. I think we're fine. I think we leave that as false for now. We're not actually doing extra blending stuff right now, so it's okay. But good to know. Good to know. And that would be in color blend state info. Let's see here. We're going to do this because I prefer when it spells this way. Color blending, S-type, VK, structure, color blend state create info. And in here, logic op enable is VK false. The actual logic op is VK logic op copy. Attachment count is 1. And the attachments is just a pointer to color blend attachments. Cool. In my original code, do I specify color blend attachments? This seems a little bit unfamiliar. Yeah, we just don't do logic op because, well, it's disabled anyways, so I guess it doesn't need to be there. Okay, yeah, that's all there. Ooh. Okay. We might be able to call a function now. Oh my goodness. Let's see. If you want to use a second method of blending, yeah, we read this. Pipeline layout. You can use uniform values in shaders, which are globals similar to dynamic state variables that can be changed at drawing time to alter the behavior of your shaders without having to recreate them. They are commonly used to pass the transformation matrix to the vertex shader, or to create texture samplers in the fragment shader. These uniform values need to be specified during pipeline creation by creating a VK pipeline layout object. Even though we won't be using them until a future chapter, we're still required to create an empty pipeline layout. Create a class member to hold this object because we'll refer to it from other functions at a later point in time. Give me app state. So let's just bump all the swap chain stuff over there. Cool. And then we create the object. Wonderful. Create info S-type, VK, structure, pipeline, layout, create info. Set layout count equals 0. And yeah. Push constant range count is 0. These are going to be 0 initialized anyways, but it doesn't hurt. It is almost time for the Hars. I will soon be free. Oh god. Right. It's happening. Today. I wish you the best, Julia. The very, very best. Structure also specifies push constants, which are another way of passing dynamic values to shaders that we may get into in a future chapter. That's it for all the fixed function states. Yeah, there's a decent amount, yeah. It's a lot of work to set all this up from scratch, but the advantage is that we're now nearly fully aware of everything that is going on in the graphics pipeline. This reduces the chance of running into unexpected behavior because the default state of certain components is not what you expect. There is, however, one more object to create before you can finally create the graphics pipeline, and that is a render pass. Exciting. We still can't even do the free yet, my god. Yeah, there's a lot. So we have our vertex and fragment stages as the first part. Then we specify our viewports, dynamic states, viewport state, and then these are the fixed function elements, I guess. Configuring rasterizer, multi-sampling, depth stencils, color blending, and then we create the whole pipeline layout with that, which I guess is empty for now, but whatever. Good, 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 good. Oh, I don't think I actually ever... Whoops. May want to actually VK create pipeline layout. Yep, I nearly forgot to do this, and that would have been embarrassing. We'll just do pipeline layout info. That's fine. Right, let's check all these other info things. Yeah, that has to stay like that. Create info is fine. Q creates info. That's fine. Device creates info. Yeah. We'll do that, because that is a little nicer to read. Image view, we'll just call that image view. Oops. Yeah, I'll just be create info. That's actually fine. Instance create info. Yeah, that's okay, I think. Cool, and I think we're just kind of like back to where we were. All right. Just change some of the names just to make them a little bit more understandable. Allocator, that's going to be null. And our pipeline layout is going to be app vk pipeline layouts. And that has to be a pointer, and I need a VK result. Do I already have a result nearby? From VK result to different enumerator. What? Ah, nope. Needs to be a VK result. Cool. SL error. Failed to create Vulkan pipeline layouts. Oops. BK results. Let me quickly just restart this and see if it solves that stupid problem, because, man, that was really annoying. Nope. LewisSnip is just fucking broken. What if I update? LewisSnip did just get an update, by the looks. If I read that correctly. Nope. It got an update before, that broke it. Because that was working literally earlier today, I'm pretty sure. Whatever, we ball. So Threshold specifies push constants. Yeah, okay, render pass. Let's do it. In previous versions of Vulkan, before we could finish creating the pipeline, we needed to tell Vulkan about the frame buffer attachments that would be used while rendering through a render pass object. However, with the introduction of dynamic rendering in Vulkan 1.3, we can now specify this information directly when creating the graphics pipeline and when recording command buffers. Dynamic rendering simplifies the rendering process by eliminating the need for render pass and frame buffer objects. Instead, we can specify the color, depth, and stencil attachments directly when we begin rendering. To use dynamic rendering, we need to specify the formats of the attachments that will be used during rendering. This is done through the pipeline rendering create info. Oh, do I have a message? I realize my phone's on Do Not Disturb, but I do have some pending Discord things, but it's fine. To use dynamic rendering, we need to specify the formats of the attachments that will be used during rendering. This is done through the, that struct when creating the graphics pipeline. Cool. Pipeline and create info, good. Pipeline rendering. Color attachment count is 1. Color attachment formats is VK swap chain surface formats. Wait. Surface formats is that. This is VK formats. Swap chain image formats. That's interesting. Okay, that's very strange. Oh, dynamic rendering goes in here then. That's fine. Swap chain image format. What the hell? Yeah, I don't see that occurring anywhere. Let me quickly check old code here. Pipeline info, yeah, that's something else. Ah, wait, hold on. My old code isn't going to help me here, actually, because it doesn't use dynamic rendering. That's funny. Tell you what we'll do. Okay. I think we're going to wrap up here because I am hungry and apparently food's ready. So I got to go get food. But that is a lot of progress. What have you got done? So surface is kind of already done. Swap chain's now done. Image views are now done. The graphics pipeline is nearly there. We're basically doing dynamic rendering and then command buffer recording. And then it's putting everything together to actually build the whole thing. Very cool. Very, very cool. But yeah, I think that is all for tonight. Everyone, have a lovely rest of your morning, afternoon, or evening, or wherever you hail from. I'm going to have food. See you around.